Hi everyone! Welcome to the third and last day of the OptaPlanner week. We are super excited for the day that is coming ahead, and we are glad that you are here today with us. So I am Karina Varela, and I'm here. I've been here with you since the first day, and I'll be here with you until the end of the day today. And let's talk a little bit about the day we are going to have. So let me show you. We had already. How does the OptaPlanner day in our event usually goes? We start with a more high-level talk, learning more about the use cases, how it was used in a couple of customers, or how we can start with our OptaPlanner projects, engagements, and things like that. We already had Duncan Doyle on day 1 and Donato Marazzo on day 2. So the talks are available on YouTube and you can find them there. On the technical side, on the middle talk, we have like at 11 a.m. EST, which is 5 p.m. CST, we will have a more middle level talk where we will talk. I'll tell you in a bit what we are going to have today, but we already had a couple of people chatting, telling us about use cases too here. So we had like Justin Goldsmith yesterday, and we had on the first day was Jerry Locker and Christopher Chianelli. So you can also get that on YouTube. And finally, we will have our deep dive talk, which we will go hardcore on usage, on advanced stuff, and how you can solve that thing that you were already trying to do and you couldn't yet. So on the first day, we went hardcore on Trusty AI with OptaPlanner, how you can combine those stuff with Daniele Zonca, Tommaso, and Tommaso Teofili and Rui Vieira. And yesterday, we had Lukasz Petrovici. I don't know how to say his name, and he knows it. Talking about constraint streams. We had a really productive conversation. It was pretty nice and exciting. So I already see you here. Hey, Menon, Benjamin, it's good to hear. Terry, hugs, Terry, Yura, how? So welcome, everyone. What do we have for today? Let me show you. So we already had our speakers, Duncan, Daniele, Donato, Lucas. And today we are going to have Satish Kale talking about business use cases and the impact of OptaPlanner. How many millions can you save when you adopt OptaPlanner to optimize your solutions? This guy has a couple of impressive numbers with more details to share, I'm sure. Then, how can we combine OptaPlanner and Quarkus, right? Let's see Radovan Sinek showing us how we can do that with a timetabling solution. And we will wrap it up with Geoffrey Desmet talking about real-time planning, continuous planning, and non-disruptive planning, and more. Hey, Antonio, Mate, let me bring these guys to stage. Let me bring them. Just a second. Geoffrey, welcome, Geoffrey.
Hey Karina, good to see you again.
Yes, third day. Are you excited?
Yes, definitely. I have
And please
and
go on.
today is my talk also, right? So that's a double excitement. It's all good.
Yeah, double excitement, adrenaline. And Satish, welcome to stage. Satish, welcome. Thank you for
Yeah.
joining us and accepting the invite to talk here today.
Hey, good morning, everyone. Good morning, good afternoon, good evening, wherever you are. It's glad to be here.
Yes. So, yes, hello from Mexico. Send us on the chat. Like, where are you now? Let us know. So, I am in Brazil, at Brasilia, the capital of Brazil right now, and it's 11 a.m. What about you, Geoffrey? Where are you based?
In Ghent, which is a city in Belgium. A very nice city, by the way.
What about you, Satish?
Yeah, I'm based out in Toronto, in Canada.
Canada, cool. Italy, hello from Italy. You've seen me doing this the whole event, right? In Italy. Yeah. Yes, Radovan is also here. Let me bring him over. Hey, Red, how are you?
Hey, quite fine, given the circumstances. That means presenting in like 50 minutes.
No worries, this will go fine. Okay.
So,
So-
Satish, we'll add your screen sharing here, and we will be able to start in 2 minutes. Can you just tell us a little bit about what's coming for your talk? Like, what can we expect?
Yeah, sure. I mean, I had a slide for that as well, what I'm going to cover. But very quickly, unlike most of the speaker, almost all of the speakers who have been experts in OptaPlanner, I'm not. Okay, what I do primarily is talk to customers, understand their requirements, their challenges, and what I do with them is basically try to map those particular requirements and challenges with the technology value that Red Hat solution offers. And OptaPlanner is one of the key technologies that we offer in our middleware portfolio. So I take that, I work with the customers, help them build those complex solutions for their requirements, help them save money as well as at the same time, propagate the usage of our technologies. And I also have a section why sales and marketing is important, although technology building, making a really great innovative product is extremely important for the continuing the future of this particular investment that Red Hat does into a technology. That technology also needs to sell. So I work in that particular sales division. So although I'm a technical person, not as technical as these other guys, nowhere close, but being a technical person, my job is primarily to propagate the value, both the technical and business value of the technologies, the innovative technologies that we build across.
Perfect.
So this today's session, okay, I didn't answer that. So in today's session, I'll talk about some business cases. I'll go in detail in a couple of them, but primarily list down. You probably have lists, okay, know all of these. Most of you guys might be knowing all of these use cases that we can cover with OptaPlanner. So I'll briefly go over them, but primarily I'll focus on a couple of them, going in a little bit detail about what was the impact of this technology over the usage over there.
So you're going much further than just seeing, okay, which technical problem do we solve, but how does it impact the organization, and what other bits do we need to actually make the story complete for the customer or for the user, right?
Yep, absolutely. And this is very important, guys. I mean, as I said, building is important, but the real value in a technology is when it impacts in a positive way to the organizations that use that, but as a let me use the term humanity as a whole. So it does have a positive impact all over, and I'll try to cover that a little bit.
Great.
Awesome. Exciting. So without further ado, let's start. Satish, I'll add your screen to your screen sharing here right now. People can see your screen, and I'll bring Radovan and Geoffrey with me to the backstage. Let's go, guys. Good presentation, Satish.
Everyone, okay. Let me see. Okay, so yeah. So firstly, about me. Karina, can you just quickly, okay, you can see the screen?
Yes, my friend, we will be here during the whole presentation. And if people, if you who are watching us right now, if you have questions, if you are interested about a topic, please bring it over. Satish likes a more interactive talk, so feel free to send it over and I'll interrupt him as usual.
No problem. Yeah.
Satish.
Yep. Thank you. Okay. So about me, I'm greatly interested in technology. That's what I had been doing for 20 plus years of my IT experience, 12 plus years in Red Hat. That's the longest I've stayed, as you can see. And no better place than Red Hat for me. I mean, on one side, within Red Hat, we nurture the innovation with highly innovative technologies, whether it is about OptaPlanner or whether it is about rules or OpenShift Kubernetes related work. All of this is super exciting. This is what gets me going in terms of sticking around, but at the same time gives us a lot of freedom in terms of making a positive impact, both for customers and industry as a whole. Again, as I said, I'm not much talented like a bunch of these guys, so I may not be contributing much in terms of building the OptaPlanner features and all of that, and hence I'm into sales. But I do take the particular value, go to the customer, take the feedback from the customer, bring it to the table to these guys to build innovation and new features. So that's my role, okay, in Red Hat. So what am I going to cover today? Okay, it's primarily about sales and adoption part of OptaPlanner. So the business cases, what's the adoption, okay, how they adopted, what was the impact, okay, what kind of business impact or okay, other impact they had. And these are some interesting stories which will help, even if you're not into doing customer facing, okay, or okay, building these solutions, but just been a hobbyist, okay, learning OptaPlanner. It will excite you, okay, or it will okay, make it very interesting for you about how innovatively people are using it and what's the impact and how great, okay, how much we neglect that particular part about the innovative technology like OptaPlanner can bring us such a big change or the huge amount of savings that they have done. So again, why am I covering this? Again, one reason is I'm not, okay, why this topic and nothing else? I'm not deep enough to cover other technology areas like these guys do. And, but primarily, okay, on jokes aside, creating awareness. Also being a kind of a cheerleader. Like I'm cheering you guys in terms of, okay, at least the people who are building this, who are kind of trying new things, new use cases and saying that, go ahead, man. I mean, you never know, okay, what these particular technology, what kind of, okay, impact or amount of savings it will be doing. So, and again, why sales and marketing matter? I'll cover that at the end stage, why it matters. But as I said earlier, okay, we need sales for a project to continue and nurture, and okay, for us to pump in more in, okay, for doing more innovation. And likewise, we need all this innovation for us to, okay, okay, make a viable business for sustaining the project. So these are all extremely important areas wherein I dwell in. So without much ado, okay, let's me jump into business use cases. And again, many of these use cases may have been already covered in the over a 3-day period or might be covered in a couple of sessions. So I'll very briefly touch them, but I'll focus on, as I said, go a little bit detail in a couple of them. Planning, as the Dr. Evil, okay, plans, you always make a plan. All the organizations make a plan, and it is one of the most intensive and sometimes most neglected or most underestimated, okay, area. And no matter how much you plan, sometimes, okay, you do not, okay, get the results as you had desired. And I understand that, okay, you can't plan everything, you can't plan to the most, okay, but by and large, what people underestimate is the impact of ill planning or lack of optimization you do in the planning and how much that particular results into whatever impact it has. And I'll give you some matrix as well as we go along. But as I said, okay, I'm just setting a stage, like planning is extremely important. And the reason, okay, people do not dwell too much attention on it is because they are not aware of the ill effects of the ill planning, or not aware of the positive benefits of the good planning. But again, when we talk about planning, we're talking about, okay, primarily as a business challenge, we look at it in a very simplistic way. You have a goal, you need to optimize, okay, based, okay, to your goals, but you have a limited resource. You always heard the term, do more with less. So you have limited resource, and then you also have to apply constraints. These constraints might be related to, okay, a people-oriented, what skills they have, what time they're available, where they are, or it could be related to some government regulations and policies or something like that. So you have to build around, okay, with the business challenge and planning, you have to have optimized of goals. You have limited resource reality of that, and you have to follow and comply with certain constraints. And this is where, okay, it also presents a big business opportunity for customers, because if you can make it more efficient, okay, and do more with less, okay, and do appropriate allocation of your resources in a right place, right time, then you can, okay, as a business, you can maximize the returns on your assets. So all these assets, whether it is the people or the stuff or the equipment they have, whether it's the vehicles, whether it's containers or cloud resources or their time, these are all assets, and you need to use it in appropriate manner so that you can able to extract as much as possible, okay, out of it in a positive way, and also improve the profitability. But at the same time, you have to balance that with employee satisfaction. Okay. And why is that important? Because in the zeal of optimization and productivity and all of that, the employee satisfaction, if it takes a back seat, then you lose people. You don't get people, okay, putting in all those through. So how you can balance that delicately in terms of doing both, doing a great business, highly productive and efficient business, at the same time keeping your employee satisfaction. And these are not mutually exclusive, and that's what we're going to talk about. So again, typical use cases: job scheduling, employee rostering, vehicle routing, equipment scheduling, bin packaging. These are some of the typical use cases. If you look at it, okay, we are mostly talking about optimizing, like you want to make your employees happy by allocating a fair amount of schedules to them. You want to make sure whatever equipment or other resources you have, you're getting higher utilization of that, and they're not lying there in inventory unused as much as possible. Or you're doing bin packaging so that there's a less fragmentation, that you're using only those in a very, very efficient manner. Or about scheduling, like you want to make sure a particular job is done on a time with the right person with right skills catering to that, or a particular person, okay, whether it's a traveling salesman or a technician visiting places, how they can do multiple jobs in a day, and what is the most efficient route they can travel around. These are all the planning things. Okay, you can't just decide like on a hunch saying that okay, this is what it is. It will be very suboptimal. And having a technology which can help you and build these particular plans which will achieve optimization will be really helpful. So moving on, again, if you have to broadly categorize scheduling, routing, resource allocation, this is what we're talking about. And there's a mix and match. There will be use cases where we'll be doing routing as well as scheduling and resource allocation and all of that. But if I had to divide, like when you're talking about scheduling, we are focusing on time. When you're talking about routing, your location, where do you want to go from A to B? When you're talking about resource allocation, we need about capacity, like what is the capacity, what is the demand, how you can allocate, what is the resources you have. And each of them have a particular set of examples. Like you, for scheduling, whether it's nurses, judges, you need to assign, whether it is about technicians or shift rostering, or in a routing case, a technician making a visit, or you want to a logistics company making deliveries. What is the shortest possible route with minimal minimal driving time and all those things. Or a bin packaging. Bin packaging could be like our shipping containers being packed in as much as you can in the most efficient manner. Or whether we are talking about really software plays, like you have a cloud resources, you have a demand coming in, how you can allocate or provision these cloud resources in the most efficient manner, so that you're not incurring a lot of cost on the cloud infrastructure, but at the same time, you're not violating any SLAs with regards to the availability of the resources for the demand that you have. So all of these are really the optimization areas where we could use the technology. Very quickly, as I said, vehicle routing, whether it is supermarkets, retail stores, transportations, or technicians, like all the big companies, utility companies, or telecom companies, they have these people, technicians visiting, or you have courier companies delivering packages. Extremely important. If their primary skills is doing what they are. So for example, technician's primary skill is going and fixing a modem or a set-top box or something like that, right? Or a unit outside of the house. Their primary skills is not driving. They're not in Uber or somewhere, right? And this is where, like, if they spend most of their time in driving and just doing, say, 2 jobs in a day, they're going to be frustrated by that. Okay, so even for an employee satisfaction, you need to utilize their time and make sure that they spend as much as they can in the things they are highly skilled in, or they probably will love. And at the same time, from a company point of view, you make very highly productive usage of their time by giving them an optimal route. Same ways, with employee rostering, you want to assign right people to right. You want that concept of fairness. Everyone gets what they are skilled upon, when their availability is there, what shifts are to be fulfilled, and what kind of skills. Like you might require nurses, you might require doctors, you might require when do you assign them. So whether it is about hospitals or whether it is about call centers, like with people with what skills are going to be there present, answering phone calls, you need coverage for everything at all time, and how you're going to make right people available at right time in what right quantity. And this is where you're creating schedules for them. So you're basically scheduling, assigning shifts to employees more efficiently based upon the skills, availability, and the time slots that are supposed to be catered to. Again, over here, employee well-being. You don't want people to attend for a couple of hours, then a 4-minute break, and another 6 hours. They will be like, okay, or 2 hours break. I mean, I can't do anything in that. So if you can combine that all together, they can get free and be out of that much sooner. So those kind of things you can accommodate, using a good planning solution. Task assignment, similar to that, you want to assign those are tasks which are to be completed, people with right resources, right tools, right, stuff with them. Can they attend? There might be a concept of, which one is higher priority, medium priority, all of those things, start date, start time, end time, when they had to be completed. All of these will be based upon any tasks that are queued up, and the employees, okay, by assigning those particular people to write tasks that they can do it. Cloud balancing, very interesting use case, and I'll give you another variant of it when it comes to telecom, okay, customers, especially with 5G, but purely cloud balancing. Now, almost everything, okay, when you talk about cloud, you're like, you have a software defined everything. You have a software defined, okay, by infrastructure as a service, like, and cloud basically makes it easy to scale up and down or spin up new stuff as you want, which also means that, okay, there is a lot more expectation from people to like, hey, I need to this particular system quickly up or quickly running. And if you're not able to automate that and add intelligence to it, you'll be probably doing a lot of manual job assigning a cloud, okay, the requests that come in and assigning the cloud resources. Now you could do it randomly in a very, okay, plain script, okay, less intelligent thing, but you will be like highly suboptimal in that. And you'll be spinning up a lot of cloud instances without utilizing them in a much optimal manner. And this is where, okay, how you can do a planning so that you can pack them in a most optimal manner so that you can extract as much as possible without affecting the viability or the SLAs that are associated with the, okay, providing that particular service. So very interesting. Okay, so in this particular example, and it can be extended, as I said, to a 5G kind of thing. If you think about cloud resources, it's about the compute capacity, memory, and all, okay, disk usage, all been made available as a software entities and on the fly being allocated. Now with 5G, okay, your network with software-defined network and everything, it really becomes easy to just treat your network capacity as something similar. So if you want to do network slicing and allocate your network capacity across multiple demands, you can do that on the fly. But at the same time, when you're planning it so that you can most optimally divide that network capacity across a particular set of requirements, which are, okay, workloads that are coming in. So what is a typical search space? Now that we know these particular use cases, let's try to understand why they are so complex. I mean, they have always been there. There are solutions around it. But why is it that we are talking so much about planning, and why is there so much scope of optimization? So let's take example of two: traveling salesman or lesson scheduling. So we're talking about the search space. So if one particular technician has to visit 4 customers, then there are 24 different combinations in which they can cover those particular. However, as you grow, okay, from 4 to 100, I mean, a technician might not visit 100, but I'm just giving a context, like there's a more than exponential. So factorial, n factorial, the search space for that particular use case actually grows even faster than exponent or a square, okay, exponent. And this is where it becomes extremely difficult or extremely, okay, the large number of data sets and combinations, permutations that we're talking now, once your search space increases. Similarly, scheduling example. So if you have 2 time slots, 2 rooms, and 3 lectures, we have 64 combinations. But suddenly, if you increase that, we're talking about 10 to the power of God knows how many, okay, number is there. And we are talking about so many zeros. And all this is great, but the biggest problem we have is that, okay, I mean, if you want to take a closer look at it, it's like we're really talking about very, very huge numbers. Okay, 10 to the power of 157 or 10 to the power of 233. By the way, 10 to the power of 80 is the number of atoms in observable universe. So obviously, you're never going to solve this particular problem by, okay, doing exact algorithms. No brute force or branch and bound method is going to work for this. The only things that will come to your rescue is the good algorithms, okay, whether it is about construction heuristics or meta heuristics, which are mostly, okay, the local search kind of thing, which gives you the most optimization. Okay, you try to find optimal solution as soon as possible. Okay, if you keep this particular running, it will run forever because you do not have enough resources in the world to find the most final optimized result. So what you do is that you kickstart that, use the right algorithm, right technology, so that you can find as close to an optimal solution as you can. Okay, and then after a certain duration, like maybe a couple of hours, you get diminishing returns that you're not up with the hours and processing put in, you're not getting that much benefit. You can cut it off and use that as an, okay, best optimal solution. Okay, and let's take, okay, now that I had promised, okay, about what do you call the business use cases, let me cover one very important one, okay, or one very interesting one. So use case one is field operations. This is primarily about man in a van. So technicians. So very big utility or telecom company. They had one of the largest in the world. They had the situation where they wanted to schedule the visits of technicians and also create the routes for technicians, the most optimal routes, because most of their time was spent behind the wheels, and this particular thing is very expensive. So these people, either they are employees or they have an hourly rate or something like that. As I said, if they are spending more time traveling or driving around, that's not good utilization of their time. They get frustrated, and your customers are still waiting for someone to come and fix their issues. This is where, we have to understand, in my role, when I talk to customers, I have to understand the aspects of that particular problem at all areas with different personas. So for a field technician, they complain that they have to do a lot more driving around and rather than working with the customer. And they have very unrealistic schedules they're getting. Okay. I mean, they are assigned to something which is not mapping to their skills or something like that. Regional manager, they have a nightmare because they are responsible for getting the schedules aligned, whether they're losing the staff because the staff is unhappy or the customer demands are increasing. And again, they have to be aware of right mapping of right people to right job. Sales manager selling becomes difficult if your customers are unhappy, if they have complained about it and your field technicians can only visit after 3 days or 4 days. You have an unhappy customer. And in these times where OTT players and all those things, they are gaining ground, they have to retain a lot of their customers and their goodwill of that. And sales managers have a different problem. They want to make their customers happy and they're not able to now. Excuse me. And the CI of transportation, they have in charge of maintaining that particular workforce. They are maintaining the vehicles, the technicians, and this cost is skyrocketing. They want to achieve optimization so that they get a better efficiency and higher productivity and whatnot. So you look at this. We are talking about the cost, the agility, the inefficiency, the customer satisfaction, and the employee satisfaction. All of these things have to be factored in. So when we think about a solution, we have to take in account of this. What complicated this use cases was we are talking about very large army of technicians, 70,000 plus technicians. And this is where it becomes extremely complicated, but at the same time, which means that it is it has a huge potential of savings because we're talking about such big numbers. Excuse me, guys. Okay. So what was the solution? So again, if you remember, I said earlier, goals, resources, constraints. The goals, we want to maximize the task throughput. You want to have fairness among employees. You also want to reduce the fuel consumption, driving time, and required vehicles. For employees, based upon the employees are the assets, resources, what do you call them? They have their skills. Like some people are good in fixing set-top boxes. Some people are good in fixing the modems. And some people are good in fixing the outside unit, the hub or something like that. And you want to assign their skills with that. And some technicians are generalists. And they may have affinity, like, hey, they would like to work in a particular region or a sub-region, and that's about it. There might be vehicles, which are also resources. They have a capacity, fuel, what time they're available, the deliveries, all those things. And then there are constraints, like one cannot do 8 hours consecutive driving, there must be a lunch break between this period, and so on and so forth. There might be also constraints related to criticality of certain tasks over the others. When you think of all of that, this OptaPlanner solution helped them doing both task management and vehicle routing in a very easy manner. Of course, OptaPlanner was a core engine, but from Red Hat point of view, and I'll cover that later on, is that we bundle OptaPlanner as a productized work in a productized manner, what we call as Red Hat Decision Manager. So Red Hat Decision Manager has complex event processing, the traditional business rules, and business optimization component, which is built on OptaPlanner technology. So this was used, and this is where they achieved both the optimal task assignment and the vehicle routing. So what was the success? So they had, as I said, 70,000 plus technicians. They had a very old and suboptimal planning solution. Assignments were poor, and they thought, there was a lot of scope in improving the quality of routing as well as job assignment. Customers were unhappy, as I said, because there was a poor delayed service. Technicians unhappy because their schedulings were all messed up, not aligned with skills. And this is the concerns. They had to account for location, where the job was there, and the location of the technicians, the skills they have, their availability time windows, the job windows, and all those regional affinity, regulatory aspects, all those have to be accounted for. And using OptaPlanner, all of these things was catered to. They built that particular solution. It's been running for more than 2 years now. And in first year, they mentioned it was very pleasing that they had massive 200 million plus US dollars in savings. And this was massive because, I mean, of course, okay, one is because the number of technicians, number of calls or visits they used to do, but also the part, okay, which is important over here is that you don't realize when your data sets increase, the potential of your optimization also increases. And the better algorithms, better technology like OptaPlanner you have, the more optimization you do. And this we encountered, like, as I said, okay, in this interesting particular team that we were working, which is okay at the customer side, we had extremely talented team. We worked with data scientists, the technical people, and all of them, and they were very much cognizant about the fact that if you increase the data sets and the data, okay, while they were doing the POC and evaluation, that will be a true measure of a technology. So initial rounds when they did, there was a big gap between what we provided, the competition, and other their existing solution provided. But as they started increasing the data sets, the gap actually widened, which made a good indicator that OptaPlanner works in a great manner, that more the data sets or more the bigger volume of data you're processing, better and better it gets compared to any other technology or options that are there. What it resulted in, productivity increase, we're talking about 20% plus productivity increase, we're talking about expedited service activations or resolutions, less fuel. Less fuel is a huge cost benefit, which also means carbon credits they are now earning. Vehicle maintenance has been reduced because you're driving it much lesser. And happy customers, issues are resolved sooner. And most importantly, the technicians are happy. They're having reasonable job assignments and less amount of driving. So as I said earlier, they're not mutually exclusive, keeping your customer and your employees happy. So what worked? The biggest thing that worked was superior technology. So we bet the competition in 6 evaluation rounds, which was awesome because it's not like, somebody felt it was a good day and evaluated a technology and felt like, let's take a lazy decision and choose a particular technology. It went through very rigorous multiple rounds of evaluation. As I said, they started incrementally increasing the data sets for more stricter scrutiny. And after that, they were of the opinion this was a superior technology, adopted it, and that was rewarded. That particular thing was rewarded by them by those huge benefits that we spoke about. So what else worked? We focused on business outcomes. Generally, when we talk technology, we don't focus enough on the business outcomes. We have to talk about business outcomes because people buy technology not because the technology is great necessarily, but because what value it brings to the table. What will it solve the problem or the amount of savings that will do? Support, the technology itself is rock solid. And one of the reasons is that Red Hat hardens this particular community projects, which are great, high in innovation, but to make them enterprise ready, we work a lot in terms of hardening it. So this particular technology in a decision manager, Red Hat Decision Manager as a product, had been so rock solid. It has been a strong support and it works. 2 years, it just works fine. The customer is extremely happy using it. As I said, savings to 30 million in first year, and I believe 100 million plus in second year. Generally, these kind of solutions, they have, and when I say additional 100 million, so generally these kind of solutions, once they're implemented, they have highly diminishing returns. Like, you have optimized as much as you could, but this particular technology keeps on surprising them by giving more and more potential to fine tune it, try to make it more real time and accommodate new constraints and factors, all of that, and make it further beneficial for them. And they just reported, this week, in fact, another 100 million plus savings for second year. Customer experience, the customer retention, and those things will be improving because, they have to maintain their customers with the amount of debt or those things the telcos carry, the amount of money they put in the 5G spectrum and other services competing with OTT players. They really need to retain their customers. So these kind of technologies can go a big way in terms of impact, helping that. Another thing, what we had to do, is that to have worked with business because decisions weren't made at technology level. We had to do deep engagement with data scientists, developers, business folks. We had to collaborate internally within Red Hat and community with regards to the practice architects, Tiger team, consulting, and founder Joffrey. He's here. He was actively involved in this. And of course, it's a tiered solution. You have to start simple, incrementally add complexity. And we were constantly engaged. These kind of complex solutions take time, a lot of effort and focus in terms of building it. Another thing which I haven't covered over here, is that the impact, regarding the impact, really to talk about, think about it. Traditionally, technical, we are talking about IT teams or maybe line of business being, impacted and they being happy about using a technology. In case like this, even the HR department, the training and all those things is important because now they are able to run simulations and say that, does it make sense to hire generalist technicians who can be assigned to any job, although they may take a little bit longer, but your overall pool size of technicians is smaller? Or do we hire or train people to be specialists? That means now you have a bigger pool size that you have to maintain, but your jobs are now getting completed sooner. So those kind of simulations you can run with this particular technology, and based upon that, make a decision on hiring, on training. And this is great. And as I said, this technology, it also does good for mankind because it helps you reduce your fuel cost. The less fuel, okay, it's better for Earth in terms of pollution or climate change. Let me quickly go through the second example. ThyssenKrupp elevator, we could take the name, okay, over here. And in this particular customer, okay, their biggest problem was basically they had a lot of escalating losses due to missed service level agreements. So they are elevator company, and they had to send technicians to fix any particular problems in an elevator which has stopped working or anything like that, and or doing maintenance, right? A periodic maintenance that is part of their agreement. And because they were lacking automation, flexibility, and all those things, they thought there was a lot of scope in terms of improving this particular process. It's a big company. We're talking about 8,600 employees, okay, 2 billion order intake, 5,000 technicians, and 50,000 employees. But 5,000 technicians is what we are dealing with, or 24,000. Okay, worldwide it is 24,000 technicians, but in US where this was implemented, they were talking about 5,000 technicians. And this is where there was a lot of, as I said, okay, the focus was on sending a right mechanic at right unit for right maintenance job at the right time. So how do we decrease the maintenance cost? And customers have to be happy. Those corporate customers were made, okay, owners of corporate or housing societies, whatever, they are owners. They are complaining about an elevator, okay, downtime or being in maintenance, how you can do that, and also decrease waste, how you can make best use of your people, the tools, everything in a right manner. And this is where, okay, excuse me, guys, okay, let me take a pause to bring in the charger, if you guys don't mind. Sorry about that, I forgot the charger.
Sure, don't worry, it's okay.
Yeah, let me.
Lucky that you noticed that before you go offline. So
I know. So guys, give me a couple of minutes. I'll be back.
Yeah, go there. Joffrey, 230 million. Like, oh boy.
What I find more interesting is that when you solve a problem with vehicle routing and you really reduce the driving time with such high percentages, is you also reduce the carbon emissions. So I actually did a calculation based on some of the numbers, and it was in above 10 million kilograms of CO2 emissions per year. So that's a lot, right? To 10 million of CO2 emissions a year. That's 10,000 tons. It's that's literally an an ecological footprint reduction. That's free. Yeah.
So you're not just optimizing like business; we are saving the world.
Yeah. Okay, guys. Sorry, you can hear me, right?
Yes.
I'm sorry about that. Okay, but anyways, coming back. Okay, so what worked? Okay, relationships. Okay, whether it is talking to right people, okay, right kind of resources, and doing a good, successful, okay, services engagement. And okay, moving on. Okay, the benefits. The big benefits were like there were lesser cancellations. There was a less gap between the skills, right? What kind of model of elevator? What kind of right technicians are there to be assigned to them? We had increased the maintenance, okay, quality of maintenance. They had a better visibility, and most importantly, the matrix 50 to 75%, okay, increase in percentage of maintenance, which is great because we're really talking about a big number here, which impacted into really what do you call marquee event for them in terms of a big thing they can brag about, and rightfully so. Because using a technology, how they can now not only save their own cost, but serve their customers in a better way. So other notable use cases that I really want to cover in whatever next 10 minutes I have is as it is like agenda scheduling, doctor appointments. We heard about that. Educational timetable, it came as okay, how do you assign lectures, exam conferences, task assignment, affinity or skills-based matchmaking, or employee shift rostering, nurses, repairmen, judges, all of them. Vehicle routing, we saw that. Bin packing. Now, bin packing is a very interesting use case. As I said, one example, containers. The another example I gave about the cloud. The third example I'll give you about was the 5G network equipment, 5G network slicing and allocation and provisioning of that. And another example that is really about the ERP solutions. We're talking about ERP solutions where people want to maintain lesser inventory, just in time, ordering and all those things they want to do. Assign those resources, use them as soon as possible. So these ERP solutions can do a lot good by including technologies like this inside them so that they can do better utilization of all the technologies they're trying to collect. Cutting costs, whether it is about any particular mining companies or they want to make right utilization of right people, the right tools, all of those. And I can give a good example, like I was talking to one of the mining person in Brazil, Karina, in your backyard. And they had this interesting use case where they said that in mining related, they use super expensive, nearly $1 million kind of big vehicle. And they are many, but the cost of operation was a big factor. And I didn't cover that, but very important thing when we discuss with data scientists and other folks is the cost of operation. I'll give you an example of technician scheduling, and then I'll come to the mining example. The cost of operation, for example, of sending a technician to fix something in some densely populated area like New York may be that high as compared to somewhere in remote place in Canada. Because a technician may have to travel 100 kilometers or more than 60 miles to go and make a particular job and then do only one job in a day. So for that particular example, the cost of operation is very high. For another one, the New York person might do 3, 4, or 5 jobs in a day. So when we talk about this particular thing, the cost of operations becomes extremely important factor apart from the number of instances, number of technicians, or number of visits, number of things that you want to align, which gives you a good example like, is this a viable use case to use OptaPlanner? Is it giving me enough benefit for me to use it? And especially in this Brazilian use case, they had, because we're talking about super expensive equipment with all its fancy gizmo stuff. And if they're not coming on time every hour or whatever they lose, it's going to cost them. So moving those super expensive equipment from multiple mining locations, they have to be super, super efficient in that. Or whether it is not just about the vehicles, it's about certain equipments, And this is where they have a huge potential in saving. The cost of operation, the amount of instances, and all of those are a big factor in there. Again, the other example, sports scheduling, even in financial things, we're talking about financial related sector. We are talking about investment portfolio, how we can spread the risk or hedging. And it would be all dependent on multiple factors, whether they're regulatory constraints, whether they are about the preferences that certain customers have in whatever their mutual funds or their investment portfolio has, account for that. And at the same time, based upon the estimates or the trends that are going, how you can buy and sell, and how do you build your portfolio, and how you can balance that out is what is a very good use case for optimization. So all of these are very interesting use cases. Let me cover a little bit quickly. The 5G equipment installation. This is not the 5G slicing. Another interesting use case is the equipment installation, because 5G spectrum purchase and the work has happened. Eventually, over a period of time, most of the telcos will be like spending time or working with their partners, who own this, or there are some telcos who actually own those places, in terms of finding the candidate list, shortlisting them, running some simulations, and then creating a prediction plot to really see that where those particular equipments, the towers, and those things, the cells, and those things should be installed. When you do that, you have to account for physics factor as well. You have to account for spectrum, how many towers, the GPS lat long, the height, whether there's an intersection or interference because of a lot of intersection. All of these things have to be accounted for. These all will form constraints when we're talking about the planning thing. But we're talking about thousands of places or hundreds of thousands of places where you could potentially do that. And if you don't use a planning solution like OptaPlanner, you surely are not getting the as much optimized solution as you can. This is a very good use case for people to start using something like OptaPlanner to chart out like what is the best among those particular choices of say 15 within a particular geographic sub region. What are those 7 or 8 which are more suitable? which will cater to the population densities or census data or whatever the data that they have. And at the same time, not shortfall on the SLAs, because as the demand increases, the spectrum, usage increases. So you have to cater to those SLAs, but at the same time, you account for physics related issues, the interference and everything. And at the same time, save cost, like do in as minimal as possible, because they have to either pay a tenant, rent it out, or they have to own it, or the leasing agreements might be very costly. So how they can optimize that is it's very crucial. Another example, very interesting, is the project job scheduling. So we had a customer who was also talking to us with the same similar example with regards to, hey, we have like thousands of IT staff, and we have a lot of hundreds of projects going on. Like we have a project where we have to do requirement gathering, design, develop, test, deploy, and we need resources like business analysts, architects, developers, testers. And there are some projects, like a project one has a dependency on project two, so project two has to be done first. These kind of things. Now you use traditional PMM and all those things, which is fine. But using OptaPlanner, you can really do the resource allocation. And once the particular set of architects are done working on project two, can some of them be applied and used in project one because their design stage is not yet started? So how you can reallocate certain resources because they will become free in whatever duration, your design phase is. So this kind of interesting use case about optimally utilizing your multiple resources with multiple persona, skills, and all of them for multiple requirements and projects that you have, how you can optimally use them. That's very good. There might be some constraints, soft constraints, like some people would like to work in a particular geographic location, and some projects may have strict requirements of coming into a particular geographic location. Some projects may have requirements related to security, like they have to be citizen of that particular country. And these kind of constraints can be applied so that right resources are assigned to right projects in a most optimal way. Again, I can go on and on and on, but let me very quickly turn about, why Red Hat? Why people turn to Red Hat and why Red Hat is good in propagating that? So first and foremost, I think most of you understand, but it begs reiterating difference between project and product. OptaPlanner week, we're talking about OptaPlanner, great, awesome project. One of the most innovative I've found. But project and product, what are they different? I spoke about decision managers. So let me talk about project. Projects are very high on innovation. The number one focus in projects is basically add features, add functionality, add innovation as much as possible. And that's how it should be. It's a development test ground. There are frequent release cycles, at least once in 3 months that happens. And the help is through forums, great people, they help it out. And the functional requirements are prioritized. So the non-functional requirements like security, ID integration, certifying on various JVMs and all those things may not be the highest priority, because priority, as I said, is focus. They can only focus on certain number of things, which is functional requirements. And this is where the enterprise users, they feel that, hey, there should be a throat to choke, some SLA-based support should be available, some sort of certification or some support team should be there all the time. And there should be a longer life cycle of a particular product, because projects are changing so frequently. We can't change something, like something is fixed in a particular version, but a new version of a project may have some new defects or something like that. Now they may be fixed in the next release cycle, but next release cycle will come with its own new defects possibly. This is where enterprise products will come in and say that, hey, take a particular snapshot of a particular project version, harden it, make it available, so that as a customer, you have that available full time in terms of for 7 years or something. And they don't have to, because enterprise customers do not want to change once they've built something so frequently. So they need some stability. They need reliability. They need something, a throat to choke if something is not working. So that means the SLA-based support and comprehensive support for ecosystem, like whether you can provide a consultant, whether your partners are well equipped in that technology or something like this. This is where Red Hat steps in and does that productization process of making the highly, highly innovative, fantastic project into very usable and user-friendly manner available to the enterprise customers. So the hidden, and here's the where, you can of course use the unsupported software and get away with that. But most of the time, there are certain numbers, very compelling numbers, which say that, hey, free is not free, really, because you have to have people who would have to support it. There might be some mishaps happening. and those have to be accounted for. There are risks associated with that. There are certain numbers. I won't go into that because this is more related to JBoss EAP, but somewhat similar numbers for any open source software. Having unsupported software is not free. It comes with its own cost. That's what I wanted to say. So as I said earlier, productized version of OptaPlanner, it is part of the business optimization component within Red Hat's Decision Manager. Now you can, as a customer, can purchase Red Hat Decision Manager, or if they're purchasing what we call Red Hat Process Automation Manager, which is a BPM solution, then it is already bundled. The whole Decision Manager is part of Red Hat Process Automation Manager. So, which basically means that we not only make it consumable, but we also make it very easy to use with the rest of the ecosystem, whether it is traditional business use rule or complex event processing, or whether the BPM and those kind of technologies. Okay. So again, I know I went a few minutes over, but basically the closing thoughts. Okay, as I said, the biggest thing: can you keep both your customers and your employees satisfied at the same time? Yes, you can. Okay, these technologies which impact the planning, optimization are closely related to both employees and customers. So this is technology which is very close to AI. Okay, I will say more closer to AI. When we talk about evolution of data, like data, information, knowledge, wisdom. So you have systems which convert data into more meaningful information because you combine and merge them. Then you have a concept of applying business rules and everything to convert the information into knowledge, which is much more refined set of information, much more context driven. But when we talk about moving on the path towards wisdom, it's basically how a self-sustaining system make a business decision or decision system, support system, which is not only based upon clear-cut objective constraints, but also because of the scoring model, make very subjective analysis on a very complex set of data and a large volume of data, is what is slowly moving towards a more evolved level of intelligence systems that we are talking about. And this is where we say that sometimes we say that it solves the seemingly unsolvable problem space. And again, the technology is rock solid. So as the biggest cheerleader for this technology, I encourage you guys to have a look at it. If you're not already using, if you're using it, think about the different use cases that it can be. And most importantly, think about the business impact, the tremendous business impact and value that this technology brings to the table. So if you're contributing to it, if you're working on it, feel proud that you're working on this particular technology. And with that, I thank you all. Okay. I know there weren't any interruptions, any questions. I didn't notice that, but if you have any questions, please go ahead.
Hey Satish, we have one question from the audience. Hey Karina. You want me to read it? Can you please provide more details about ERP solutions, specifically inventory management and sales predictions?
Yeah, yes. Inventory management is a very interesting. We have one of the vendors, who provides a very great product on ERP, and asset management, and we are kind of having discussions with them, and Joffrey, you're involved in that. It's basically when you have and I have a production engineering background, so I know this operations research and ERP and project planning and all those things. Somewhat. It's been like more than 20 years now, but still I recollect all those things. It is extremely important to keep your inventory cost low, to procure things when you need them. And there are a lot of dependency when you're building something. You're assembling something. You require 100 different components. When are they made available? Your whole project planning will be messed up if one of those items are missing. A right person who assembles that, or who builds that, or who paints a particular thing is not available. And this is where, how do you plan ahead of time? So generally what people do is that they provision everyone all the time. And you have a huge inventory, not only of the equipment or the resources, raw material, but also about the people who are going to work on it. Using OptaPlanner, if you can plan it ahead of time when things are to be made available, all of those things will be accounted for. Another interesting aspect is that this is a very, very volatile world. Any weather event happening, whether it's technician visiting a site, anytime something happens, you can actually, although you have planned something, and if some mess up happens, whether it is like roads are closed or riots or an event related to like an earthquake or something, inclement weather is happening, and you have to reshuffle or reschedule stuff, you can just run this and it will rerun that particular smaller set of algorithms, set of data set, and will replan it for you. You don't have to rely on people making just call or keeping people on bench to address that. And this is where this technology helps. But again, coming back to your asset management, tremendous potential because we're talking about resources, we're talking about their availability, their time, the kind of the constraints they work on it. You have to account for all of that. I'm sorry, I missed the second part. One was the asset management. What was the other one?
Sales predictions. Not sure if OptaPlanner could help with that, but OptaPlanner can actually optimize on top of sales predictions, which is really the interesting part, right? Yeah.
Absolutely. I mean, I guess sales prediction is really, really complex area. And again, you have to account for a lot of stuff like your marketing events when they happen, people who are given the feedback or rather reaching out. And it comes in an overall customer experience and engagement and that kind of solution, but it is a very core engine. It may work as a black box inside your overall customer experience related stuff, but this is where they can talk about what is the customer's buying preferences and all of those. You can collect and use that data more meaningfully. What has been the trend? What is their availability? Where are they now? What is their purchasing capacity? When you account all of that, you can now find out what is the right set of product or services you can pitch to a customer based upon whatever constraints, availability, and interest they have.
And we have Radovan joining us. But yeah, that's a great presentation. Thank you, Satish. Thanks for all the numbers. Thanks for all the information. The numbers were really great. Let's see if there's some more. If there's more questions, ask them on the chat, guys, and I'll share them. I'm taking over for Karina for a few minutes, but she'll be back in a minute to continue hosting this event. Hey, Karina. We have upcoming now. It's the top of the hour, I guess. Yes. Upcoming is Radovan Sinek. He's a core contributor to core committer and developer to OptaPlanner, and he'll be talking about how to use OptaPlanner to solve a high school timetabling problem and with Quarkus. And he'll actually show a bunch of code there. So that's going to be a very technical, very interesting talk, but a getting started talk. Really, what do you need to know to start with OptaPlanner in 2020? Because we're going to use the latest things we have in there. He's going to use the latest things we have to really minimize the amount of code you have to write. And we have some good things and some good news for the presentation. Some people really happy about the presentation. It was really nice. It's really good to see the business side of things, really, and the business use cases and the differences and all the different things where we can apply. Thanks, Satish.
Thanks.
So, Radovan, are you ready?
Yes, I am.
Floor is yours.
Thank you. Hello, everyone. Can you see my screen? I guess you can.
Yes.
So welcome to this presentation. My name is Radovan Sinek. As Geoffrey said, I'm part of the OptaPlanner development team. And today I would like to show you how to use OptaPlanner for creating a school timetable. First of all, let's talk about why we should be interested in OptaPlanner or in the optimization AI in general. Satish covered many different use cases, so let me just quickly recap some of them. We might be interested in scheduling some shared equipment. We want to maximize its utilization. Or we might be interested in optimizing execution of jobs that depend on each other. And our goal is to minimize the make span. Maybe we run a fleet of vehicles and we are delivering packages to our customers. We want to save some driving time, the fuel consumption, and also the environment. In the cloud environment, we have some hardware with certain capacity of CPU and memory. And our goal is to schedule execution of processes that demand these resources. And we want to have as little fragmentation of the computation resources as possible so that we can operate more efficiently. Imagine we are running a hospital and our job is to schedule shifts for doctors and nurses. We have to take into consideration their skills, their specialization, but also their preferences. Somebody would like to have night shifts on Friday, and what if some nurses need to take PTO next week? We also need to maintain fairness to keep employees happy. So these are some examples of the use cases. And as Satish mentioned, for example, the vehicle routing is capable of saving hundreds of million US dollars per year and tons of CO2 emissions.
So Radovan, your voice is sometimes a bit weird, but it's very understandable. If you, so I would continue to talk like this. I'm just saying if there's an easy fix. Please continue.
Let me a bit amplify the microphone. Is it a bit better?
Yes, that's better. Thank you.
Thanks. But today I would like to focus on a different use case. So this is how classrooms like go.
Yeah, it was just worse for a second than before. Yeah, please continue. Now it's good again.
All right. Now they are probably already full of students. And the first thing the school staff had to come up with is the timetable for the next school year. So what does this job actually involve? We have students organized into groups, like here, 9th grade. And we have some lessons these groups of students are supposed to take. And these lessons are taught by individual teachers. We have also some rooms where the lessons should take place. And we have some time slots. Now we need to take all the data into consideration and come up with something like this. Here, for example, we see that the math taught by Mr. Turing takes place in the room A, starting at 8:30. Sure, this is easy because we have just 4 lessons, 2 rooms, and 1, 2, 3 teachers, 2 student groups. That's not a problem. This is an example of a trivial problem size, but the real school timetabling has to deal with tens of lessons, teachers, student groups, and rooms. So it's far more challenging. As we saw in the previous lessons, that such a problem doesn't scale well. If you imagine this real problem size, it's no longer trivial. It's something which can take hours or even days to figure out manually. It would be nice if the school staff didn't have to go over this exercise year after year. And of course, there are already applications capable of generating school timetable. Today, we will show how to create such an application using an open source constraint solver, the OptaPlanner. This is the result we are interested in. A web application where we have the time slots, the rooms, and the lessons already assigned to them. Let me first talk about the architecture of the application a bit. I promised you a web application, so apparently there will be some web UI, some web page, which communicates with a REST interface here. And there is also a database we store the results, the finished timetable to, and of course, the OptaPlanner itself. The entire application runs on top of Quarkus, which provides us with quick and smooth redeploy, minimal memory footprint, and also the possibility to compile the entire application to a native image. But today I would like to really focus just on this box over here, the OptaPlanner. OptaPlanner is written purely in Java. It's an open source project which has been around for over 10 years. If you open the documentation, the first thing you learn is, let me just read it aloud. It's a lightweight, embeddable constraint satisfaction engine which optimizes planning problems. That's a nice long definition, Geoffrey. So first, let's have a look what planning problems are. Let me show you on this example of the vehicle routing. Each planning problem has its specific goals. Here we want to minimize the fuel consumption and thus also the ecological footprint. It's always nice if you can save both the money and the environment. Planning problems usually have some resources which participate in the plan. Here our resources might be the vehicles which are delivering packages to customers. An important thing is that the resources are always limited. We don't have infinite number of vehicles. And the last thing are the constraints we have on the solution of our planning problem. Our more fine-grained expectations regarding what the solution should meet. So here, for example, the vehicle capacity. Each vehicle has a maximum capacity of what it can carry at any moment, and apparently we can't go over this capacity. And the distance each vehicle has to drive, it's something we want to minimize because this is directly connected to our goals. Now, the bad news about planning problems is that they are difficult to solve. And there is actually no guarantee of finding the optimal solution. If we have trivial problem sizes, like the 4 lessons, 2 rooms, 3 teachers, we can do it with brute force search algorithm in a reasonable time. It's just a small problem size. But for other than trivial problem sizes, the brute force search or exact search algorithm will take thousands of years to finish. Apparently, we don't want to wait for so long. Good news about the planning problems is that constraint solvers like OptaPlanner can find a near optimal solution in a reasonable time. And once we have a solution, we can quickly verify if the solution is good enough for us. Because again, we know our goals and we have defined the constraints. So this is the way how to measure if the solution is good enough. Before we jump to using OptaPlanner for this case, let's first quickly check if the school timetabling is a planning problem. What could be our goal? Maybe we want to make both students and teachers happy, or at least we don't want to make them suffer. Now imagine a timetable which is full of gaps between lessons. Nobody likes it, right? Do we have any limited resources? Sure we do. We have a limited number of rooms. We also have a limited number of time slots. And what could our constraints be? We would like to allocate all the lessons. Also, we can't afford having a single teacher giving multiple lessons at any moment, at the same moment. That's a limitation of the real world. So is the next one. At any moment, there can be up to a single lesson in each room. And the last one, as we talked about it here within our goals, we want to minimize gaps between lessons. So yeah, this looks like a valid planning problem, something OptaPlanner could help us with. Now, after we identified a planning problem, we need to somehow translate this problem so that OptaPlanner can understand it. We need to somehow describe the nature of the problem and also the constraints. As the OptaPlanner is written in Java, we will describe our planning problem as a set of Java classes. And when we are developing this problem domain, we have to ask ourselves two questions. What is the entity that changes during solving, so-called planning entity? And in this planning entity, what references should OptaPlanner change for us? These are called the planning variables, because this is really how OptaPlanner works. It takes a look into the instances of the planning entities, and it changes the values of the planning variable references. And each time, every such a change introduces a new working solution. And for every working solution, we have to be able to tell how good the solution is. We have to be able to calculate score of the solution. To do this, we can use, for example, the constraint streams API. If you want to know more about constraint streams API, be sure to watch the yesterday's talk, Getting Started with Constraint Streams by Łukasz Petrowicki. So this is, again, Java API. It was inspired by both Java 8 streams and also by SQL syntax. And when we are implementing the constraints, the scoring function, we have to think about which of the constraints are hard and which are soft. Now, hard constraints must never, ever be broken.
Hey, Radovan, mind if I interrupt you for a second for a question from the audience? So
Sure, go ahead.
Thank you. It's a slide back, 2 slides back. Jeff Wright is asking if about the math equation that is used to calculate the size of the possible solution set. So for the high school planning problem. So for example, we have 20 lessons and we have 10 rooms and 10 time slots. How many possible solutions are there? How many ways can we assign those lessons into those rooms? And I would presume we probably have more lessons, right? In reality, like maybe 200 lessons, right?
Yeah, so this is probably about combinatorics. So I don't remember the equations exactly, but if I remember the math, I think there is also factorial involved in the equation. So this pretty much illustrates how quickly the size of the problem grows. So if you increase the number of lessons, it's maybe exponential or even beyond exponential. So this really isn't something you would like to search the entire universe of all possible solutions.
So for example, for traveling salesman problem, it's indeed factorial. It's the number of locations you want to do a factorial. So if you have n locations, it's n factorial. But that's because once you assign a location, the next one, because it's chained when we change variables. But to answer Jeffrey's bright question out there, it's a bit difficult here because we have 2 planning variables, which makes it more complex. So we have the rooms and we have the time slots. But basically, every lesson can be assigned to a combination of room and time slots. So if you have, let's say, 10 time slots and 2 rooms, that's 20 possible locations you can put it in, right? So 1 lesson has 20 options. 2 lessons has 20 times 20 options. 3 lessons has 20 times 20 times 20 options. 4 lessons has 20 times 20 times 20 times 20 options. So when you have n lessons, it's actually at 20 to the power n. So which basically means it is your rooms times your time slots, and that multiplication to the power of number of lessons. And that grows quickly, very easily, right? So you can easily have to 10 to the, if you have 40 lessons, that's to the power of 40, right? And that becomes really, really big numbers. Sorry for the interruption.
No, thank you, Geoffrey. So we were talking about hard constraints. So I said that hard constraints must never ever be broken. If they are, our solution is not feasible. Let me illustrate it on the example here. So if we have a room where two different lessons are taking place in the very same moment, such a timetable doesn't work. It's a broken hard constraint, and no matter of the assignments of the other lessons, this is not something we could publish. So hard constraints are usually used to model limitations of the real world. On the other hand, soft constraints can be broken. They usually model the cost of the solution. So if we end up with having some gaps in the timetable between lessons, it's something we can probably live with. Of course, we want to minimize any occurrence of gaps, but if we don't have enough resources, like enough rooms, yeah, this is probably the way to go, because we can't break the hard constraints. We can break only the soft constraints. But enough theory, let's get back to the application. As I said, the first step we need to do is to develop the problem domain. So here we have three classes. The first one is the time slot. It has some day of week, start time and end time. We have also the room, and the last one, the lesson. Each lesson has some subject, teacher, and a student group. And also it has a reference to the time slot and another reference to the room. Now, OptaPlanner's job is to assign instances of time slots and instances of rooms to the instances of lessons to these references so that it breaks as few constraints as possible. Our job as developers is to tell OptaPlanner that the lesson is the planning entity and the time slot and room field is the planning variable. Let's have a closer look. The application runs on top of Quarkus, so if I run maven clean compile Quarkus dev, it will start the application in the development mode, so that it will automatically redeploy the code with any change. Let's see if it's already available. Oh, here we go. So this is our UI. Here on the left are the available time slots. Here on the top, we have the rooms, room A, B, and C. And down below are the lessons. At this moment, the lessons haven't been assigned to any time slot nor a room. Here is the score of the solution. The -40 in it means that the solution hasn't been initialized yet. Where does this number actually come from? So if we take a look, we have 3, 7, 14, 20 unassigned lessons, right? And remember, each lesson contains two planning variable references, the time slot and the room. So the -40 means we have exactly 40 references to planning variables, which are null at the moment. Let me start the solving and see what happens. So OptaPlanner quickly initialized the solution. As you can see, there are no unassigned lessons left. It's trying to improve the solution a bit further. Depends how much time we give. And if we now check the solution, we can see that there is no conflict on the rooms. That's okay. So let me check the timetable by teachers. And as you can see, this is not okay. Here, Mr. Turing is giving 2 lessons of math to 2 different student groups at the very same moment. This doesn't work. But the score suggests that no hard constraint was broken because the hard part of the score is not negative. So let us check the source code. Let's start with a walkthrough the domain classes. So here is the lesson. As I said, it's our planning entity. And inside the planning entity, we have the planning variables, time slot, and the room. The planning variable annotation takes a parameter, which is a reference to a value range provider. The value range provider tells OptaPlanner where to take all the possible values for this variable. And we will find the provider here in the class I haven't mentioned yet, the timetable. This class is marked as the planning solution, and the role of planning solution is to put together all the information about the planning problem. So here we have a list of all time slots, which is marked with the value range provider annotation, and the IDE time slot range, which is the reference here. So this is the source of all values for the time slot planning variable. The same applies to the room list. Again, value range provider. We also have a list of all lessons, which is marked with the planning entity collection property. This tells OptaPlanner, here are all the instances of our planning entity. And finally, below is the score of the solution. Now what happens if we click on the solve button? The request is handled in the timetable resource, namely in the solve method. We call here some solver manager, solve and listen. So what is the solver manager? As we are using Quarkus, the solver manager is injected into the REST endpoint. And this API takes 2 type parameters. The first one is the planning solution, in this case, the timetable. And the second one is planning problem ID, an identifier of the planning problem to be solved. So on the solver manager, we call the method solve and listen, which takes, again, the planning problem ID and 2 method references. The first one deals with the input. So before the OptaPlanner starts solving, it has to somehow load the input problem, right? And it will do so by calling this method. If we take a look, the find by ID queries all the time slots, all the rooms, and all the lessons from the database and creates a new instance of the timetable. As the first method reference is dealing with the input for OptaPlanner, the second one is dealing with the output. Each time OptaPlanner comes up with a new best solution, each time it improves the score, it saves the new best solution to the database by calling the save method. But our problem doesn't lie within the REST endpoint. Our problem is connected with the constraints. So the last interesting part of the code base of this example is the timetable constraint provider. Here we implement the constraint provider, and namely we have to implement define constraints method, which takes a constraint factory, something we can build our constraints from, and an array of constraints. It's recommended to define each constraint as a separate method because it's more readable, and also it allows unit testing of individual constraints. Let me show you, for example, the room conflict. So here, how do we detect a room conflict? A room can accommodate at most 1 lesson at the same time, which we can translate as if there are 2 lessons taking place in the same room at the same moment, It's something we want to avoid. It's something we want to penalize the solution for. Now we somehow need to detect these pairs of lessons. So we start from the constraint factory, and we call from, which takes a class as a parameter. At this moment, we've got unique constraint stream of lesson. Now we join. Remember, I said it was inspired by Java 8 streams and by SQL syntax. So from join is quite similar to the SQL. If I join again with lessons, I will get a by constraint stream. So I will have tuples inside of the lesson and again a lesson. This part would construct a Cartesian product. But I'm not interested in a complete Cartesian product, so I need to somehow limit what goes down the stream. We said we want to detect pairs of lessons that happen in the same time slot. So I will use joiner equal lesson get time slot. This is a method reference. And when it pairs the lessons together into the tuples, it will call this method on each instance and check if the time slot is equal. If it is, this is the pair which we can let down the stream. So now we have pairs of lessons that occur in the same time slot. Let's add one more joiner to have pairs of lessons that also take place in the same room. And last thing, we are interested only in pairs of different lessons. So we need to filter only lessons that are different. Lesson 1 doesn't equal lesson 2. And when we detect such a pair of lessons, we penalize it for the room conflict for 1 point of the hard score, because this is hard constraint. Now, as we can see, the teacher conflict hasn't been implemented yet. And I will start from the constraint factory, which is the entry points to using the constraint streams API. And this time, to make it more interesting, I will use the from unique pair. What from unique pair does? From unique pair does exactly this together with this. It will give me a by constraint stream of lesson and lesson again, and it will make sure these pairs of lessons in the stream are different. But that's not all. Now we have to use some joiners, because with the teacher conflict, what we are interested in? We are interested in detecting pairs of lessons, pairs of different lessons that happen in the same time slot and are taught by the same teacher. I will match the lessons on the same time slot. And also I will match them based on the same teacher giving the lesson. When we detect such a pair of lessons, we can analyze it with a teacher conflict. If, again, 1 point of hard score, because this is another limitation of the real world. This is a hard constraint. All right, from unique pair of lessons that happen in the same time slot and are taught by the same teacher, penalize every such a pair for 1 point of hard score. Let's give it a try. Let me rerun the solving. Again, the solution was quickly initialized, and OptaPlanner is still trying to find some improvements. So far, so good for the rooms. No room conflict introduced, which matches the information about zero hard score. And let's check the teachers. Yeah, it works. There is no teacher conflict. At any moment, every teacher is giving up to a single lesson, which is okay. Now, by looking at this solution we've got, is there anything else we might possibly improve? Let's have a look. For example, here, Madame Curie is giving the first lesson of chemistry in the room C. Then she has to move to the room B for physics. And after that, she returns to the room C. Let's say our teachers are not interested in moving between rooms, between the lessons. Let's do something about that. We can call this constraint teacher room stability because we want our teachers to stay in the same room. How does it translate to constraint streams talk? We want to detect lessons that are taught by the same teachers and take place in a different room. I will again start from the constraint factory, and I will use from unique pair because it's again about pairs of lessons. Now I have a pairs of different lessons. I said I want to detect pairs of different lessons that are taught by the same teachers. So joiners equal lesson teacher. So I don't have a joiner for not having the same room, so I will use something else. I will use a filter, and the filter takes a by predicate because we have a by constraint stream of lesson and lesson. So we have a by predicate which takes lesson 1 and lesson 2. And if we do this, lesson get room not equals lesson 2 get room, we just detect the pairs of lessons that take place in a different room. And let me penalize such a pair of lessons, this time for teacher room stability. And what do we use now? Hard or soft? Now we must realize that this is in fact not a hard constraint. It's nice if the teachers don't have to move between the rooms, but this is definitely something we can live with. So I will use 1 point of soft score. So this is the constraint. We construct a by constraint stream of lessons that are taught by the same teacher and take place in different rooms. Let's see what happens. Let me run the solving once again. Let's give OptaPlanner a moment to come up with some better solution, because as you see, it's still evolving. So let me quickly check for the conflicts, the room conflicts. I don't see any. Teacher conflict, it's okay. Now, by the way, we also don't have any conflict for the student groups, which is also welcome. And let's check the results of the last constraint. So as we can see, all the lessons of Madame Curie are taking place in the room A. And Mr. Turing is giving lessons of math only in the room B. And we can quickly check the other teachers. Yes, nobody has to move between the rooms. So hopefully we have just created a timetable everybody is happy with.
So there's another question from the audience, if I may ask you. So Euro is noticing that this presentation, many presentations of OptaPlanner these days use Quarkus. And he's wondering if you prefer Quarkus over Spring Boot. And if so, why? Can you show some of the advantages, or at least what do you like of Quarkus?
Yeah, so what I like just during the presentation is the very quick redeploy. Have you mentioned me compiling anything, doing anything? No, I just switched from the IDE to the browser, and just to be 100% sure, I just refreshed the page. But actually, when I tried a dry run of this presentation, it works even without the reload of the web page. I may have as well just clicked on the solve button without refreshing the page, and everything works. Another advantage, as I mentioned when talking about the architecture of the application, is that with Quarkus, we may compile this application into a native image so that it can, again, quickly redeploy, no JVM involved.
Yeah. I love those features too. If you can just show the quick refresh again by maybe breaking the application. I'm thinking maybe in a value range change, put a typo in there or somewhere.
Yeah, that's
a compiler won't
fairly
get
easy, I would say. So yeah. I just comment out the penalize. So now this type is definitely not a constraint, because constraint is returned as a result of the penalize call. And now if I refresh it, all right, but luck, it's broken. So let me just uncomment the part again.
So
well, apparently I have to refresh, but yeah, we are back again. So yeah, that was fairly quickly, I would say.
Yes, definitely. I really love it how it's less than a second before you can see it again. It doesn't take 3 seconds.
And I don't have any supercomputer here. I have mere 2 cores.
Nice. Thank you for explaining.
So let me just shortly recap what we did here. So first of all, we have to identify our planning problem. And then we start with translated the problem to OptaPlanner so that we can optimize it using OptaPlanner. The first step is to develop the problem domain, some Java classes, and to think about what is the planning entity, or what are the planning entities, and what are the planning variables. The next step, when we are done with the problem domain, we have to somehow measure the score of our solution. We need to implement the scoring function. I have shown you the constraint streams API, but there are several other options like incremental score calculation if you need to go just for the top performance of the score calculation, or dual score calculation. So that's the next step. And the last step, you just have to submit your planning problem for solving. You can use, for example, the Solver Manager API for that. And that's what I wanted to show you today. So thank you for watching.
Great presentation. Thank you for sharing. So we have an audience member asking if there's if this example, including the web interface, is available on GitHub as well.
Yes, it is. I think recently it was moved to a standalone OptaPlanner Quick Starts repository available under GA group on GitHub. So there you can easily find a couple of other examples, but also this one.
Yeah, and it's also available on Quarkus.io. So let me just do that as a banner here, right? Create a banner. Not quite sure. Is it showing up? Here we go. If you go there, the full example guide is there, and you'll find the link to the code also. There's a copy in the Quarkus Quick Starts and also one in the OptaPlanner Quick Starts. So great presentation, Radvan. We have a bit more time. We have more. Let's see if there's any more questions from the audience. We haven't checked all things yet. Great talks. Okay, we have a couple of people really liking the talk. That's great news. Here we go. Right.
Thank you.
So then let's take a look. There's one question from the audience. It's really for the Fireside talk. Satish, do you want to join us? Let's take a look.
Yeah.
Hey, Satish. Join us. Let's take a look. Here we go. So one of the questions from the audience was about quantum computing. So the question is, I'm curious to know your opinion on the effect of quantum computing, how that might affect constraint solvers. So could this be confined to solve much bigger problems like carbon emissions globally? Anybody here wants to take that question? I'm happy to take it.
Yeah, go ahead, Geoffrey. I can add it.
Yeah. So quantum computing is actually very interesting. So one of the promises is that of quantum computing is that they'll be able to look at all possible solutions at the same time with qubits and so forth, right? So what they use is and the amount of let's put it like this: the amount of lessons they can look at the same time, and presuming that each lesson is assigned to just a binary variable, so a 1 or a 0, is defined in qubits, right? And right now, I'm not sure what the number of qubits there are, but I think it's been a while since I've catched up. It's more like 80 or 100 qubits. And I see Duncan's joining us, so let me just add him to the stream. Hey, Duncan.
Hi, guys.
Okay. So the question is about quantum computing. So will one day quantum computing replace all traditional solvers? Maybe, but I do believe that day is not going to happen this decade or the next decade. But there is a good chance. It's a very interesting technology. The real challenge will be once we have quantum computers big enough to deal with any real life problems, right? With real size problems where they can easily solve these kinds of problems, is that how do we program them? How do we add a constraint in there? There's some interesting talks on there, a couple of videos, a couple of workshops if you want to try it out. There's actually one by IBM I'm aware of on how to try to program for a quantum computer. I tried it and it's really mind-boggling because it's not writing an if loop or a for loop. It's not even multi-threaded or something like that, or functional programming. All that stuff is easy compared to programming for a quantum computer, at least as of today. So the real challenge, I think, for the industry is how can we, once quantum computers become, serious enough and have their error prone is low enough to actually be usable for real world things, how can we also make them, once we have that, how can we also make the tools to use them, the programmers how to define them, easy enough to actually solve business cases and make it do it in a maintainable way. And at that moment, I think it's going to be a great opportunity for the OptaPlanner project to take a look and see what's going on there, right, at that point in time, given the experience we have in this domain. But and for the second part, on how can they solve much bigger problems like carbon emissions globally, we can solve that today, as we've shown with OptaPlanner. We can really, as Satish showed, we can really reduce the number of cars we need and the number of miles we need to drive and kilometers we have to drive on the road simply by optimizing them better. I'm not saying that, and to give you some numbers, we reduced the driving time in cases 25% is a very common number that we see in vehicle routing. However, if we save 25%, is that enough to actually, to solve the entire carbon emissions globally? Probably not. It's going to need other things, right? But it will at least reduce the stress on the number of these resources we need, right? Anything, Satish, you would like to add, Duncan, Radvan?
No, I mean, the only comment I'll make is that there will be certain coexistence, and there will be use cases which are more suitable for quantum computing and cases which are more suitable for these NP problem solving scenarios that we have. There's a lot of overlap that we anticipate, but again, it will come down to the amount of customization with regards to the infrastructure provisioning or infrastructure availability, specific quantum oriented computers or the servers that are being there, and how on one side, if you want to achieve compatibility or backward compatibility, if you have to call, of running those particular algorithms on non-quantum computers, oriented computers, would you get an advantage that you wouldn't generally get by that? So how are you going to split your problem into something solved by quantum computers, something solved by traditional means by constraint solvers? This is going to be an uncharted area for us. But as of now, we see that these constraint solvers are going to be here for a while. And there will be some more exciting new AI-oriented use cases, which might be first choice in terms of using quantum computers. But again, we are not there yet in terms of having a lot of concrete, meaningful. We are just dipping our fingers in it. Probably next year or in a couple of years, we'll have a much more better answer. We might be including that into our solutions, hopefully, right, Duncan?
Obviously.
Yeah.
But there is this joke in the industry, right? And they make the same joke about fusion reactions for fusion reactors. So the joke is quantum computers are 10 years away, just like fusion reactors are 30 years away. And that was true today, and that was true 10 years ago, and that was true 20 years ago, and that was true 30 years ago. They're always just 10 years away, right?
Yeah, it's the same like free beer tomorrow. Exactly.
I hope that's there. It's Friday.
You've never seen that sign, free beer tomorrow, and you end up next day there, and there's still that sign, free beer tomorrow. It's the same principle, I guess.
Yeah. And did it work? So you showed up twice.
Yeah, I show up. Every day I have to hope that this day will be the day, but no, it never happened.
That's how you raise VC money, I guess.
Exactly.
Yeah. I do see things moving. I do see that they're increasing the number of qubits that they can solve, and I do see that you can do some initial programming against them with low numbers of qubits. The programming is also quite interesting. What they say is then you basically have to, your operators are like spin the quark. What is it? Sideways? I forgot. And it's so I'm asking. So where I can just do add and minus, and those things aren't really there, right? Which makes it interesting. Maybe there's.
And also, Geoffrey, talking about the carbon emissions. I mean, it's not just about the planning of when you are sending a vehicle or your airplane routes and those particular things. Even in the case like the maintenance part, predictive maintenance of say airline engines. It seems remote, but it eventually how effectively you can do that, how frequently you can do that without costing too much. Even those kind of minor things will add up a lot in terms of over a period of time, in terms of how these engines and those things perform at the most optimal level and the most cost effective, or rather in a environment friendly manner. Those are the things. I mean, in these days, we are not flying too much, but soon we'll be reaching, hopefully, in that particular stage where there will be a much more better planning, much more optimized routes, much more optimized, combining of those. There's a lot of, people-oriented transportation that happens over a flight or shipping and all of those, which all contribute to the carbon emissions. And if you optimize all of that, if you do better maintenance of the equipment, if you merge certain routes or those options that you give by running a lot of simulations, you're effectively impacting in a positive way for carbon emissions.
Yeah, I'm a strong believer we can still do a lot in a win-win situation where you don't give up any comfort and you reduce the carbon emissions. I personally, I don't believe it's going to be enough. That's a different discussion. But let's start with doing the ones where we don't have to give up comfort, right? It's just such a waste that if we can do the same job with 25% less mileage, less fuel consumption, let's just do that. It's a win. It's a win-win for win for the environment, and it's a win for the organizations, right? And it's a win for the customer.
It's funny because I think we've seen a use case like that, what you described, Satish, that in a lot of industries, this was in the airline industry actually, that the replacement of parts of an engine is done so oftenly that they really replace it at the point where probably that part would be able to be used for another 3 months. But because they don't know, because they don't have the information about the status of that part, whether it's at 99% of performance or 80% of performance, they replace that basically on current standard schedules. And you now see, well, this is what one of our customers explained, that they are starting to use more and more data from the planes itself, like when they're flying, to analyze what kind of usage of these parts they have, so they can better and more optimal schedule the maintenance of those parts. And that really showed that they were basically replacing part as 99% of performance, where they only had to replace it from regulation perspective at 80% of performance. And these were parts of like $10,000 each. So do the math, and you can see how much waste there actually is, unnecessary waste, and where we can improve not only a carbon footprint, maybe, but also all the parts of an engine that can longer be utilized in between services.
Hi, everyone.
Karina!
I'm back. Did you like? I will need to rewatch this last part because I can't believe I had to miss the presentation about Quarkus and OptaPlanner. Was it mind blowing? Was it? Wow. So cool. I see we have lots of people here today. And next we are going to have, let me share my screen. We are going to have Geoffrey Desmet, the great Geoffrey Desmet. The internet shakes with Geoffrey.
So now we know that you also had a coffee, Karina, or a Red Bull. You're full of energy again.
By the way, we still have a couple of time. Did you talk about Cogito and how it relates to OptaPlanner? Did you?
You're asking me
so far,
or
yes?
You're asking anybody in general?
Yeah, all of you. We cannot hear
you, Geoffrey.
I'm just setting up my environment for a second, so please excuse me for a minute so we can screen share decently.
Okay, sure.
No, I came just walking in, Karina, so I've got no idea what these guys have been doing. I came into an interesting conversation about quantum computers and carbon footprint of fuel emissions.
So tell us about how OptaPlanner is linked to Cogito.
So Cogito is our new initiative for cloud-native business automation. So that means rules and rules, processes, and business optimization. So OptaPlanner, and what it basically aims to do is it aims to grab the libraries and the platforms that we've been building out for years that you know and that you love, but make them more cloud friendly. So that means less resource utilization, faster startup times, etc., etc. And we do that by using a technology, well in this case Quarkus and GraalVM, to allow us to what you would traditionally do at runtime. So a lot of the things that you would traditionally do at runtime, that takes resources, takes memory. Bring that to compile time to make applications that are optimized, that are smaller, and which is especially important when you're in resource confined environment. Well, not really research confined, but it's more where you are in environments where you actually have to pay directly for the resources you consume. So there's no point in, for example, loading a bunch of XML libraries if you only use those at startup time and pay 200 megabytes of RAM on your container. If you can bring those things into compile time. So there's a lot of techniques that we use to make these applications smaller, faster, more suited for these new container and cloud deployments, to basically make better use of the resources that you pay for in your public and your private clouds. So that's Cogito in a nutshell. And now I have to
You said all of that, but you didn't explain it properly. How do we say it? Like
Cogito. It's Cogito. It's not. Yeah.
Why? Is it like? Is it,
yeah.
Are you saying it based on your accent, or is it like really how it is?
No. So we. I still think that the name is extremely cool, but sometimes I wonder why we didn't choose another name that was more easy to pronounce, because I've heard this name pronounced in so many ways that's not funny anymore. Especially in America or any English native country, it's always Cogito. I don't know why, but they always say cogito, but it's not cogito. It's cogito. It's actually a Latin word, or it's a wordplay on a Latin word. It's a wordplay on cogito ergo sum. Yeah, I think, therefore I am. Very, very good, Benjamin. I think, therefore I am. And in Latin, it's cogito with a C, but we replace it with a K, obviously, because that's for Kubernetes. And if you want to have a cool name in an open source project nowadays that is related to cloud, it has to start with a K. So what can you do? Okay, so
I'm super cool for the cloud.
It's exactly. You're super cloud native. The funny thing, to explain one more thing, because we've got 1 more minute before Geoffrey starts his awesome talk, is the logo, because we had a Jira about the logo. So the logo of Cogito, I have to disappoint you. It's not a pirate. It's not Mario Fusco. It's actually a I shouldn't say that when you take a sip of your drink, right? It's actually a Viking. So it's Odin. So the question was, why is your logo a pirate, and why is the pirate winking? So it's not a pirate, it's a Viking, and the Viking is not winking. The Viking is missing an eye. It's actually Odin that who sacrificed his eye for wisdom. So it's not only wordplay on cloud, it's also with wisdom and knowledge and intelligence.
You need to change it. OptaPlanner. OptaPlanner.
Exactly.
So one thing, guys, because we are on the top of the hour, T-shirts for the attendees. I try to do it, but it's so hard to ship it over to all of your houses. I would totally love to do it, but I couldn't. So maybe on the next year, or whenever we are going to have this live, I'll surely bring lots of stickers, T-shirts, everything about OptaPlanner for you. Okay, I promise. So that
and this
being
is
said,
recorded, Karina. You realize that, right?
I know.
No promise.
I know.
Okay,
I
good.
promise.
Okay, just saying.
What goes on internet stays on internet. Okay, forever.
So, can people use like everything we're talking here to bring into curriculums for universities, or create workshops, create their courses, whatever? Since this is an open source project, would they be allowed to do it?
Everything is Apache license, which basically means you can use it, you can modify it, you can redistribute it, you can do whatever you want. The only thing you cannot do is claim that, take the brand and abuse the brand somehow. So, start selling pizzas that are called OptaPlanner.
That would be unethical. Who would do that? Come on, it's OptaPlanner. That would not be nice.
So, wanna start, Geoffrey?
Sure. My screen sharing is ready now, so let's take a look.
Good.
Sure.
Enjoy, man.
Please
Yeah.
change to the slide share. Good.
Yes.
I am now showing your screen and removing everybody from the streaming. Thank you, Satish. Thank you, Red,
Yeah.
Duncan. See you soon. Good presentation, Jeffrey. Have
Thank
a good.
you. Thanks, Karina. So today I'll be talking about planning agility. So the need for continuous planning, real-time planning, non-disruptive planning, and things like that, right? And a couple of other concepts around this. Now, we actually had two ways to intros, two quotes around this. So the first one is from Winston Churchill. So two proposals to prefix the title. And the first one was from Winston Churchill. And let me see if we can get rid of this. Okay, that's not really helping. Okay, it will have to stick there for today. Okay.
Do you want to try to remove it?
No, it's fine. Let's just keep it.
Okay.
So the first one is from Winston Churchill, and he said, "Plans are of little importance, but planning is essential." So what did he mean by that? Well, I think he meant by that is that if you have a plan, it's probably not going to go according to plan. There's always something that's going to change in the problem input and so forth before it actually goes into execution. But he said planning is very essential because, and that's very true, right? The worst thing you can do is have no plan. It's always better to have a plan that doesn't really go according to plan than not have anything at all. And we'll take a look what that means for our use cases and our business cases that we're working on, of course, right? Now, there is a famous boxer who said it in a very different way, but basically the same thing. And that's, of course, Mike Tyson, the heavyweight champion. What he said was when somebody asked him, so one of the reporters asked him, your opponent has this plan, is going to go do this, go left, go right, and so forth. And he just simply answered, like, everybody has a plan until they get punched in the mouth. And it sometimes does feel like that. If you have a plan and once it goes into execution, just before something happens and the plan is very much disrupted by that. So let's take a look at what kind of planning disruptions we might see. Well, I would argue there's two types: a local disruption and a global disruption, or at least a disruption more across the board of your company. Even if you have a company that's, let's say, only active in France, you might see a disruption that actually affects all of your stores or all of your locations and so forth, right? So, and let's take a look at some examples of both of these. So the local disruption one is quite simple. You have a plan. You're going to take a certain employee will be covering a certain shift or a certain task, or a certain technician will be driving a particular vehicle, and that person is sick today. He sends that in maybe the day before, maybe an hour before, maybe just at the moment that the shift actually is supposed to start. So that's a very disruption because you were presuming that person would do that job. It's actually an additional problem if that is a person with a rare skill, and you might not have a backup for that and so forth. So that becomes interesting, right? There's also global disruptions. And so one particular global disruption was the September 11 attacks in 2001. These particular ones affected especially the airlines, because the airlines traffic was shut down in North America for 2 days. What's interesting about this story is that many airlines at the time did not have any form of automated planning. And it took them up to 5 days to actually get their airplanes in the air again. So in 3 extra days they lost, not because they couldn't fly, simply because they couldn't get their plans together to actually fly those planes. And you might wonder, why is that? Well, it's quite simple. When you send a plane, let's say from Paris to Washington, and that flight gets canceled, well, that physical airplane is not in Washington where it's supposed to be to go to pick up, to do the next flights leaving from Washington, right? And the air crew which is supposed to be in that airplane isn't there either, right? And the airplane you're going to use immediately afterwards, but the air crew will have to sleep, and so that's going to be in another flight, and then they're going to fly somewhere else, right? So the moment that you basically, say, we pause the whole schedule for 2 days, then, and let's say it happens on a Monday, by the time it's Wednesday, everybody's supposed to be somewhere else than they're supposed to be, and you have a global disruption across the whole thing. And so the airlines that actually had at least some form of automated planning, even if it wasn't a very good one, they could actually get their planes in the air much faster. They did it actually after they'd only had a 2 or 3 day delay, unlike the 5 day, which most ones had. Now, a little bit later, a few years later, there was another one global disruption, and again, it hit the airlines. This was the volcano eruption in Iceland. I'm not going to pronounce the name, Duncan, of that airplane before you ask, but it shut down the air traffic in Europe for 8 days. So 8 days, they couldn't fly, and afterwards, again, they were in the same problem, right? And of course, we all know that afterwards, everything has been brilliant in the airline industry. I mean, no clouds on the sky, of course, except, of course, for this year. Again, they got hit quite badly. And due to many flight cancellations, it really affected all of their planning. And again, automated planning is a good way to deal with planning disruption, right? So there's this paradox that I often see. I sometimes see that, okay, we cannot automate this kind of planning because the plans will change. And so we need the humans will need to change the plans anyway. So it's better just to let them do the plans. That works as long as the plans are very isolated and as you don't really care about optimizing those plans and so forth, right? But when you want to optimize those plans, well, and when you have global disruptions and so forth, you really need to think about to automate your replanning, to just be able to deal quicker with disruptions, even if they're local or global, doesn't really matter, right? But of course, this has an effect. You need to make sure that the code we write, the OptaPlanner implementation we do about this, or with any other constraint solver, that it actually is able to handle planning changes, right? So what are the techniques here? So the question is how? How do we deal with planning agility? And I would wish there was a single answer, like this is the answer. Now we do have the answers, it depends what you want to use, and sometimes you want to use combinations even. Now, before I go into what exactly you want to use, I need to ask you a couple of questions. So what is your publication deadline? Think about that for a minute. Think about your planning problem, your scheduling problem, and ask yourself, what is the publication deadline? So what is a publication? Is the moment when whoever's doing the planning, the human planner, the machine, the manager who's sitting behind the machine with OptaPlanner solving it, actually says, okay, it's ready. I'm going to give it to the employees, right? So I'm going to tell the employees when or how or where to work or any combination of that, or the machines if no employees are involved whatsoever, right? But I'm basically going to publish the plan. And so what I notice is that every use case has a publication deadline, right? And it's a good question to ask when you come into a new case. So what is your publication deadline? How much time in advance do you need to share your plan with everybody who's involved in that plan, or at least the majority of the people who's involved in that plan? And so what happens is in technician routing, for example, like the vehicle routing case that Satish showed earlier, it could be up to just 1 hour before the department. The technicians know that they need to show up at the depot, and they know they'll be going home in the evening. And in between, they don't really care where they have to drive to in advance. They just figure it out. They will arrive and they will look at their route. They will put the right stuff into their vans, and they will leave. And as long as the hard constraints of the routes are met, that's all fine. For school timetabling, for example, you can't do that. You cannot say to the teachers and to the students an hour before the new school year starts, look, here's your school timetable, like the case that Radovan showed. You need to do that. You need to actually stop quite a while before that. I would argue a week, but I've seen schools actually do it just a day before, because school timetabling is a very hard problem, especially if you do it manually. As Radovan also showed, just making sure that the hard constraints are met is already extremely difficult, let alone soft constraints, right? So again, you want to do this way before the end of the vacation, or maybe even a week before the school starts, or maybe a month before the school starts. I mean, you are affecting the lives of the teachers. You will be affecting when they will be home during the week and when they will have to work at school. Guards and nurses, the same thing. You are affecting people's lives, and much more randomly even. So every time you release a new week for the guards or a new nurse for the nurses, you will be deciding if that nurse can go to that party. Well, nowadays she won't be, of course, but if she can at least be home with her family, take care of the kids, or he can take care of the kids, and so forth, right? So you want to do that sometime before, and what I've noticed is it kind of depends on the sector and also the company and so forth. But with nurses, it tends to be more in advance, but their schedule seem to be far more erratic than guards. So guards typically have like 4 days in a row off, 4 days. For late shifts and so forth, right? And any sort of combination. And the last one is the facility location problem, which I haven't talked much about it, but this is where we have a quick start for this now, a Quarkus quick start for this now that we're building. Jira did a really nice one about that. And what we're doing in there is we're assigning but we were deciding which locations we will open a new store or a new warehouse or something like that, a new facility. And we're going to try to do that as optimally as possible. There's a variation on this with 5G masts and so forth. But the thing is that this happens way before we actually do it, right? We actually execute the plan. This actually happens like 6 months before it, right? So what we see is, if you just visualize this for a minute, whatever kind of planning we have, there is this publication deadline, as you see here, and there's this execution start, right? So when the publication deadline, we need to deliver, we need to send out a plan before the publication deadline hits, right? And this is the moment of publication, of course. Usually they coincide. People usually wait till the last moment to actually release the plan, right? So, and this could be hours, like in this case. So the execution of the plan is on 28th of February at 8 o'clock, and it could be like for vehicle routing case, we actually deliver it at 4 o'clock. But it could also be that it's weeks in advance, like for nurse rostering or guard scheduling, right, where we deliver it weeks in advance. Even though nurse rostering and guard scheduling would be called operational planning still, it's far more out, right? It's far more advanced, far sooner. And then there could be, and there's cases of strategic planning, like hiring new nurses or hiring new guards or deciding where to build a warehouse and so forth. And you'll be actually figuring out your plans months in ahead, right? That's really on a strategic level. And what's interesting about these things is how they affect each other. You could have strategic planning cases that affect your tactical planning cases, which can affect your operational planning cases, right? So let me just give you some examples of that, of these. What's it? Just have a feeling what kind of planning problems you have there. So for strategic, could be for nurse rostering, could be, do we want to expand the maternity wards, right? Do we want to allow more women to give birth in our hospital because there's a need for that, for example, or another hospital is closing? And when we do that, of course, that will have an impact on our nurse scheduling, because we will need more nurses and so forth, right? And more doctors and so forth. Technical, do we want to hire a respiratory specialist? Do we want to hire a maternity nurse? Because a normal nurse cannot just work in a maternity. A normal nurse is not a respiratory specialist. For example, around COVID, respiratory specialists were the nurses you want to hire, because they have that rare skill that you will just have a high need around, right? And then operational, of course, we need to assign, do we want to assign Monday shift to Anne? So if we hired extra respiratory specialists, if we built that maternity ward, that will actually influence in the options and the freedom we have to assign Monday shift to Anne. It will actually depend on it. So these planning problems depend on each other. Each planning stage feeds into the next. So just to give you another case where it's really where it's even more tightly ingrained, especially for trains and airplanes. This is sometimes a bit mind-boggling. But strategic-wise, do we want to stop in Philadelphia? So when we have a train going from let's say Washington to New York, do we want to add a stop in Philadelphia? It means that the train ride is longer, but we could carry more people, sell more tickets, right? Technical, do we depart at 7 a.m.? This is influenced by the whether or not we stop in Philadelphia. If you have to be in 12 o'clock in New York, because that's our time slots to actually arrive there, and the train track is available then we need to leave earlier in Washington if you're going to stop in Philadelphia, right? Operational, which locomotive and wagon will we use? Will we use the fast locomotive, which can actually, get those top speeds or not? How many wagons were we going to add behind this? And again, this matters whether or not you stop in Philadelphia, because the more people you carry, the more wagons you need. It could also be affected by if you leave at 7 a.m. or not, because that wagons might still be in use on another train. Those locomotives might still be in use on another train, right? If you, it all depends, right? So especially in those cases, those things really depend on each other. But here's the big problem, right? If you look at these cases at their publication dates, they are separated by time, right? And while you can solve, when two people are separated by location, you can solve that by coming together. If you are separated by time, unfortunately, as far as I know in this universe, you cannot. So, which basically means that this is the same for publication dates of planning problems. Planning problems that have a different publication date cannot be using the same solver instance in OptaPlanner. Right? So if you have something that have different publication dates, don't use the same solver instance. Don't start adding multiple planning entity classes. Don't start adding multiple planning variables. It's not going to work. You need to have one solver that comes up with a solution that gets published, and then sometime later, the next solver will get that as get the decisions that are made in the first solver, in the strategic solver, as basically hard constraints in this solver. And of course, you can do some feedback mechanisms like Banner's decompensation and so forth. But big point is that basically this one comes first and sets the terms there, right? And if this solver doesn't do a good job, or if it's too tight, if you try to save too much money on this level, turns out there's too few employees actually get all the solving done, then you have a problem here. And of course, there are solutions there. We call this over-constrained planning. In that case, you start hiring intern nurses or something like that, and that becomes quite expensive. So there goes your money. Gain becomes a money deficit, of course, right? But you can get that feedback back to this department. Another interesting thing about these is that when you look at this, Conway's law applies. So what's Conway's law? Let me read it out for you. Any organization that designs a software system, he just said a system, but it's a software system, will produce a design whose structure is a copy of the organization's communications structure. So let me try to turn that around just to make it a little more understandable. The planning problems solved by different groups should use different solver instances, because if two groups are, so if it's not one, if two groups are today solving a planning problem, and you're going to try to replace that by a single solver that solves the whole problem for all groups, you're going to run into a problem that you're not just trying to solve a software problem or software architecture, you're going to try to solve an organizational problem. And so you better study some parts about human resources and so forth, right? Change management, basically, in organization. It's a very, very different challenge, a very, very big challenge. I'm not saying it's not possible, but the advice I always give is during the first year in production, make sure you do it the exact same way as it's being solved right now by either humans or existing software. And the next year, second year, think about throwing some of these, if there are multiple partitions or regions, think about throwing these together so you can have additional scale benefits. And the third year, it's time to let's take a look at the once you have both solvers running of both the operational level and the tactical level, or the technical level and operational level, then of course not if they're on different stages, right? But if they have the same publication deadline, this third year, then you can actually start trying to merge those two groups, but then you have a change management problem. So it's the software part is actually the easy part of the challenge there, right? So What does this mean in practice? So here's a case. We have a train wagon to decide which train wagon we will assign for a train ride, for example, for the train ride today leaving at 9 o'clock. And we will also have to decide where this train will, at which platform it will stop in New York. So if you remember in any train railway station, you'll see there's multiple platforms. So it has to decide which one will stop. And some of these platforms are longer. They can accommodate for longer trains. Some of these aren't shorter, right? So the deciding on how many wagons and which wagons you put on there could actually be an influence to which platform you could use. And you could probably say you should solve that as one single planning problem, because you both decides the wagons and the platforms at the same time. And that's probably, in theory, in utopia, the best way to solve it. However, if today your train wagon group and your train wagon department is a separate group from your train platform department or platform decider group, don't do it like that. Don't start out like that, because you're trying to walk up a wall. Take the stairs. Start with first implementing this, get this in production, and then start unifying them. Right. So here we can see the wagon solver being called, and at a later time we do the platform solver. So, second question: do you assign to time? So what does that mean? So sometimes you don't assign to time. So here's an example where we don't assign to time. We're assigning the cloud balancing problem processes to computers. You don't see any notion of time there. Yeah, it's just, this is the state we want to get to, right? If you make any changes, we'll just reassign the processes to get to that new state. There's no notion of time in this domain, right? So you can basically see this, because if you actually looked at the domain model and so forth, there is no notion of no Java.time import. And I'll explain later why this is important, but this actually influenced some of our choices later down the line about replanning. So the other option is, yes, my domain has time, but the planning does not assign time. So what do I mean by that? So here's an example of the hospital bed planning problem, where we're assigning patients with a certain name, with a certain arrival date and a certain departure date to a bed. So we're deciding which bed, in which room, in which ward this patient will be. And now the interesting thing about this is that we don't get to choose the arrival date or the departure date of the patients. That's already decided together with the doctor earlier. That might be a tactical planning problem, and this is an operational planning problem. So that was a different solver maybe, or maybe it was handled just by picking up the phone and saying, oh, look, there's a gap in the surgeon's agenda. Let's do it then. Doesn't really matter. What we need to do is we need to figure out what's the best bet given a number of preferences. Like, for example, this person wants a single room, and of course, if we put people in a double room, the gender should match. So don't put a male and a female in the same room in the same night, right? The hospital bed does not change the patient's arrival or departure date. So this is the planning variable does not affect these things. So that's an interesting thing. So that's another case. But then of course we have the third case. But before we jump into the third case, where OptaPlanner actually does change the assignment to time, let me talk a little bit about Java time and so forth. You can see I'm here importing a local date time. Oh, that's a mistake. But I'm importing a local date. But by the way, don't use Java util date for time manipulation. Let me just rant for you about that for a second, because asking Java util date for a calculation around time, it's asking like your bartender how to treat cancer. Yes, you'll get an answer. Yes, it will sound good. It's not going to be accurate, right? Java util date has problems and issues all around it. Daylight saving time is just the tip of the iceberg. Now, some people say, okay, in the old days, it then said use Java util calendar. Don't use that either. That's even worse. That's at last asking your dog how to treat cancer. It will just bark at you. At least that's my experience. It is an horrible API. Luckily, they realized that the Java founders and so forth. So what they did is, thanks to Stephen Colborn's work, by the way, they added a Java.time package. And since then, we have brilliant support in Java for any time manipulation. So the big two to know there is local date and local date time, right? So local date if you just have a date, and local date time if you have a timestamp. if you are a company that's all across the world in different time zones, you might want to change this into zoned date and zone date time and so forth. But of course, that depends on your use case. I would recommend, if you do not have that use case, please stick with the local date, right? Default to local date until proven otherwise, right? And or local date time, right? Or local time, depending on the case. So here's a case where, let's say we're in the case where, yes, our domain has time and those planning assigns to time. So then we need to pick a good model, right? So let's take a look at a couple of the options you have. Assigning time to planning entities, because it does affect our planning agility problems, right? So the first option you have is, I'm going to use the time slot pattern. This is one of our design patterns, which is explained in our manual. But basically what you're saying is, and we use this for the school timetabling problem, for example. We have a lesson like math theory or chemistry or math exercises. And we're going to assign it to one time slot, right? And also in this case to one room. The point about this is that the time slots, as you can see, this one goes from 8 to 9, this one from 9 to 10, but here's a recess break, starts at 10:15. Point about this is that we cannot assign math theory to 8:15. No, we can only start it to the time slot that starts at 8, right? All the time slots are equal in length. Do they have to be? In fact, actually for this pattern, they don't have to be. For the conference scheduling example, we have conference talks that are different in length. So like here, lessons are different in length. But of course, the long lessons will only go into the long time slots and the short lessons will only go into short time slots. You can't mix, and so that's one of the limitations of this pattern. Now, so yes, here we have the same duration for all planning entities. You can extend it a little bit, as long as we cannot say we're going to take 2 short lessons, put them in a long time slot. So that's once you have that, the time slot pattern is no longer your friend, is no longer what you're looking for. So another option we have. So let me just show you what's the code behind it. So we have a lesson here. This is the school timetabling problem. Well, actually, Radovan just showed it, but just to take you to it again, the lesson has a subject, a couple of other properties, and it has this time slot variable, and of course that's importing some Java load time here. Notice here that in this particular slot, and this is something to think about, we're not assigning a lesson to a date. We're assigning to a day of week, like Monday. Monday is not a date, right? It's not, the 1st of February might be a Monday, but the Monday is not the 1st of February. It could be the 8th of February, and we are assigning it to a start and end time. So that's quite interesting. So why is that? It's because we schedule 1 week for school timetabling, but we repeat that every week until the end of the semester, right? So it's really, we're just scheduling 1 week, and then we just copy paste that forward. So that's why it doesn't even have a date, because it's not, it's not just the first week we schedule it. We will copy it to the other weeks. Now, so besides the time slot pattern, we also have the time grain pattern. So the time grain pattern is actually a more flexible version of the time slot pattern, I would argue, where you're saying, instead of assigning these lessons, or in this case meetings, to a full time slot, we're assigning it to a time grain, which is basically the start of a time slot, right? So these time grains are, you can see that as starts of time slots. But so what we do is we fill up the time, the planning window, with time grains of a certain granularity. In this case, it's 15 minutes. I wouldn't recommend going to 5 minutes. I've seen cases where 30 minutes, an hour, or a day fits, then use those. I've seen very few use cases where 5 minutes actually makes sense. If you tell people to be on time on 5 minutes, they could do it, but it's unlikely that you want to schedule things on a 5 minute granularity. Going below that, saying to somebody, your talk starts at 8 o'clock, 0 minutes and 5 seconds. That's saying it, that's useless. Just say it starts at 8 o'clock, right? So that's why. So when you do time grain pattern, think about your time granularity. And the reason I want to keep it big, like 15 minutes, that's actually already very small, is because it affects the search space and also the efficiency of the solver. In fact, time grain pattern isn't that an efficient way to solve. Let's look at the chain pattern in a minute, and that's usually far more efficient. what is the advantage of this? Is that it can pick the gaps. So it can decide, look, I'm going to keep a gap in this meeting room, in room B, during time grain 7, which is apparently from 9:45 till 10 o'clock. We'll keep a gap here. And you could make that, 2 time grains or 3 time grains if you just take this brown event and just move it down a little bit to the right. What is a requirement here is that all of your meetings are rounded to a number of time grains. So like the green one is 4 time grains, the yellow one is 6 time grains, the purple one is 1 time grain. So you need to actually specify in a multiplicand of 15 minutes in this case. If you look at the change through time pattern, which is of course the pattern we always use for vehicle routing, task assignment, project job scheduling, and so forth and so forth. This is a very common used one, is that we basically don't assign these planning entities to directly to a time. We just assign them an order. We say Anne first does the French taxes, which is task to calculate the taxes, and then does the Spanish taxes, right? And Beth does first the Dutch taxes, then the Belgian ones, and then the German ones. And the interesting thing about this, these calculations can now be any amount of time. They don't have to be divisible by 15 minutes. So this one is 52 minutes, this one is 47 minutes. So basically the next task, the next entity in the list starts when the previous one ends. So there's no gaps to decide. And that doesn't mean there's no gaps. It just means there are no gaps to decide. Because here OptaPlanner can decide in a time grain pattern, I'm going to leave 15 minutes or I'm going to leave 30 minutes, which is a feature you might want. But in many cases, what we see is that we can actually use a chain pattern, which is again far more efficient usually, and still have gaps. So how would that look like? Let me show you. Here's again the chain through time pattern, but this time there's gaps in there. So how do the gaps work? Well, this is a vehicle routing problem. Anne is going to drive to the WTC building. Then she's going to drive to Wall Street. And then the next day she'll drive to 44th Street and then 49th Street. Now, the interesting thing is when she does a Wall Street, drives over there, it actually crosses her lunch break. So the moment it crosses her lunch break, we actually pad this task or this delivery or this drive with an hour. Because we know somewhere in this time, she will actually, stop for an hour with working and get some food, right? Get some lunch. Then what we see is we get the same thing here. So then there's a sleep thing. So and then we notice, well, we could after we go to Wall Street, we could still drive to 44th Street, but we're never going to get there before 5 o'clock. So our variable listener, our shadow variable listener, what it actually will do is it will actually push this forward and start the arrival, the arrival time at 9 o'clock instead of trying to append it here. So we have some minutes forwarded. But again, it's also the shadow variable that's going to pad in this lunch. This is all done by custom shadow variable. You can see that we do the same with vacations and sleep and so forth. We just pad in the time, the gaps, to make sure that we fulfill our requirements, such as making sure that every employee has a lunch break, or gets to go home at 5 o'clock, right, and so forth and so forth. So that is how we can actually enrich chain patterns with gaps. There's a fourth pattern called the time bucket pattern, which we use, for example, for elevator maintenance, scheduling, and so forth. What you basically do is you take a time bucket of, let's say, 1 day or 1 week or something like that, and you add in a number of tasks, a number of jobs that need to be done. And then what happens is you make sure you have a certain capacity on how many, how big those jobs can be. For example, here you can do 3 yellow jobs of sewer inspections, and together, as long as they don't take longer than 8 hours, we can throw them into one bucket for that. This has some downsides if you compare this to vehicle routing, because we don't decide the order in how we will go from A to B and C, but it has a big upside, and that's because there's far less micromanagement here. While if you use the chain through time pattern, you're telling to people in which order they will do their tasks, right? In a time bucket pattern, you're just telling them, here's your tasks, how you do them, and you figure out which order you want to do them. You can still optimize on a whole bunch of things, like if these tasks are in different locations, try to get them at the locations that are near each other. But you're not going to get the vehicle routing efficiency of actually getting the shortest route. So it's a trade-off, right? But in many cases, it can actually, it's a good idea to do this. Depends on the use case. Not for vehicle routing though. So now that we learned that planning variables, planning entities can be dealing with time and can actually assigning them in time can be a planning variable or not, and still time could be in there. Let's talk about some of these ways to actually solve these replanning cases, right? So do you replan every week or every day or every hour? And if the answer there is yes, then continuous planning is probably your thing. So what is continuous planning? So if you remember from employee rostering, we're assigning employees, as you see here on the side, with different skills to shifts. So there's a morning shift, afternoon shift, or a night shift. You can see some of these shifts have skill requirements, and sometimes they're free, right? So what happens in continuous planning is, well, we make a planning, right? This is the publish notice, and before the publish notice happens, this is the plan we make. We're telling basically that these 3 nurses, that this first nurse, this first is a designer actually, will do 3 morning shifts and then a late shift, and the last nurse here, for example, will do 4 night shifts and so forth, right? And then the middle one has a couple of days off. What we actually do is in continuous planning, we change it a little bit. Instead of planning 1 period, typically 1 week, what we do is we do that 2 or 3 times in length. So we actually plan 3 weeks. The first part we call the final draft, and the rest we call the draft. And after that we call unplanned. So why do we have a period that's unplanned? It's because we cannot say let's plan until the end of time, right? Until the heat death of the universe or something like that, right? No. What we need to do is we need to limit that. Just memory restrictions on CPU and so forth, of a machine and so forth. So and it's also not interesting to look forward than maybe 1, 2, or 3 times the draft period. So but we don't want to just do the last draft because that would paint us in a corner. I'll get back to that in a minute to explain it better. So what happens a week later? Well, a week later, we plan it again, but this time, this part, the final draft, was published already, right? And so we're now later, we're now Tuesday or Wednesday or Thursday. So this part was published, we can't change it anymore. We're planning a new part, so the next few days. And of course, we've extended the planning. The planning window is again the same length, so we've actually extended we added an extra week at the end, right? So and when we kept doing it like this, again, a few days go by, and then again we need to deliver a plan. What we actually get is, this is called continuous planning. We get a planning window that moves from, of course, through time, where we always have the same amount of time that the same planning window that we're solving. It's always the first part of that, usually the first week. That is the final draft, and that's the part that we're delivering. That's the part that we're publishing, right? The other parts, as you can see here, they just go in there next week, they get replanned, and they might have changes. Like, for example, here we had a night shift. Well, here that turned into a day shift, right? So why? Because new information came in the back. Or maybe some of the requirements here changed. Maybe somebody asked for a free day before this was published, and we couldn't do the original drafts anymore. So this is continuous planning. So when you do continuous planning, you need to make sure that anything that's in the history, all right, that doesn't change, especially if it's already happened, right? So what you do is, here we have a shift where we have the start and end date, and we need to assign this to an employee. Notice that we don't assign the shifts in time. We actually assign the employees in time if you look at the other way around, because when we assign a shift to an employee, the employee gets assigned to 1 or more shifts, right? But anyway, we have a Boolean history here, historic or something like this here, and we put a planning pin on that, which basically means that if this Boolean is true, then this shift will not change its employee, and the employee will not be changed by OptaPlanner, by the solver. And so that's a good way to make sure that, look, OptaPlanner, you can change everything in the draft piece, but you can't change anything in the historic piece or in the published piece. So if you want to do it on the published piece, this is the exact same approach, of course, but now this is called a Boolean published. And of course, anything that's historic is also published. So the historic ones won't change either. So if this one is true, then we won't change it anymore. But let me think about that for a second. The shift hasn't happened yet, but it is published. So we have not the intention to change it anymore, the assignment. Does it mean it won't change? Well, probably. Let's think about that let me come back to that in a few slides. So continuous planning with a rotation. So how does it work? So here's a more elaborate example. We have a number of shifts, so morning, afternoon, and night shift on every day. So every column here is one day, like the 1st of February, 2nd of February, 3rd of February, and so forth. And right now we are about, I guess, the 4th of February or something like that. We have a published deadline to figure out what we're going to do 3 weeks from now, by the 8th of February, right? So we need to decide what is the plan for the 1st of March. So let me just show you. This is the plan that we need to make. This is what our solver is solving, the draft part. These parts, the published part has been published earlier, but we have a contract that says to our nurses or security guards or whatever the case may be, that 3 weeks in advance, we're going to tell you when you will be off in the week of 1st of March, right? So when you can meet up with your friends because you don't have to work. Now, as this now line gets closer to the publish line deadline, before that happens, we need to deliver this part. So when that do, you decide, okay, this is the final draft. That's that week that we're going to publish. So the publish length here is just 1 week, and actually in almost all cases I've seen it's 1 week, if at least it's a week granularity. We have cases with hour granularity too, of course, but that's not what I'm explaining here. What basically happens is this final draft becomes published, written in stone, or at least wood, I would say. I wouldn't call it stone. And the rest stays draft, and we add, of course, another, just like I've shown earlier, another number of shifts to the end of the the planning window, which will need to be assigned during the draft, right? This is basically what happens after we publish that 1 week. So what do we have here? We have a publishing deadline, we have a published notice, we have a published length, and we have a draft length and a final draft. So a lot of terms here. Things to know is that the published notice is how much time in advance the people need to know their schedule. The draft length is how big is your planning window that you're solving with a normal planner run. So when we're changing the normal things, because we will also maybe we'll need to change the published part, and I'll get back to that later. But here we're just running the solver through the draft part, right? So don't paint yourself in a corner. How do you paint yourself in a corner? Well, for example, you assign all of your respiratory specialists, which you have, which is a rare skill, to the last shift of your planning window. So if we look at this and we go back a second, we assign all of our respiratory specialists to all kinds of shifts here at the end, including normal shifts that a normal nurse can do, but we just, they can do those shifts too, so we assign them to it. The problem is not here. This will be a perfect schedule with a very good score, but when you then try to solve this problem the week after it, all of your respiratory nurses are unable to work that first day, or at least that first shift on that first day, because they just did a night shift the day before. So you painted yourself in a corner. So don't do that. And how do you do that? Well, what I've done here in this example, you just have a draft length, right? You have a draft length which is longer than your published length, and then the amount of the week that you're publishing. Instead of solving for 1 week, you solve for 2 weeks or for 3 weeks, right? So your draft length must be at least your published length. That's a good advice there. Okay, so we can see how that affects that. So okay, so the published notice can range from long to short, weeks or seconds, right? So in weeks we do employee rostering or pharmacy on duty scheduling, and seconds can also happen. Runway scheduling in an airport, or gate scheduling in an airport, platform scheduling for trains. And in these cases there might not be humans involved, but you're still doing continuous planning. There's time involved, and as time goes by, you need to schedule things. Often you will combine continuous planning with real-time planning, which I'll get to in a second. So what we notice here is the domain must contain dates or timestamps. So you probably see a Java time in there in your domain. And the planning windows must overlap. If they don't overlap, you're actually in the case of school timetabling, right? Where you just say, okay, I have one planning window that I'm solving, and I publish that. I might actually copy that, but the next one there's no overlap, right? So you need that window overlap before your continuous planning, before you need to use like the planning pin trick and so forth to make sure that you replan every week, right? Otherwise, it's just two separate planning problems who don't have anything to do with each other. So in school timetabling, planning the first semester or the second semester, they are completely, they are independent, right? You might, some decisions you've made in the first semester might affect the second semester, but there is no continuous planning there. So the next question is, will the published plans change, right? I've alluded to that, it's called, and if they change, we want non-disruptive replanning. So how does that work? So remember our multi-stage planning here, right? So we had strategic planning decided months in advance, tactical planning weeks in advance, operational planning hours in advance. And so at that point in time, we figure out that's the plan, that's how it's going to be, and then things like this happen, right? In a strategic plan where you decide to hire new people, maybe somebody resigns and you would have to hire more people, but it actually takes sometimes, in some organizations, it could take quite a long while to get the budget around to actually hire somebody. In technical planning, you decided that nurse is going to do that shift, and then all of a sudden it turns out that particular nurse needs surgery and will be, and she tells like a week in advance of the plan execution that they won't be available for that plan. You will need to figure out somebody else who does that job, right? But meanwhile, your plan is published, right? And you're likely going to have to change the published plan, which is something you want to do that's a painful thing to do. If you change it a little bit, you can do it. You can just call the people who are involved in those changes. If you change it completely, you have to call everybody, gets everybody's approval. And I can assure you one person will not be okay with moving its shift because they have a birthday party somewhere that they need to attend, right? And they don't want to do a shift at that time. So, and of course, operational planning like technician routing and so forth. Any vehicle can break down. Any technician can call in sick for a day, and it can happen up to a few seconds before the execution starts, or even during when it happens, right? So in conference scheduling, we're assigning, just to explain a little bit how to think about this, we're assigning conference talks to rooms and time slots. So we have a number of rooms here, we have a number of time slots, we're assigning a number of talks to certain time centers. So we did this for DevOps last year with OptaPlanner. So the thing here is that when you look at the schedule, there's a call for proposals, there's a CFP deadline, there's acceptance of and rejections of proposals, at which time the solver can start deciding, after they know which talks will come there, which talk will be in which room and at which time, right? And so this is where we run the solver. After the proposals are rejected, unfortunately, we do not help in there. I would love to, so when they know these are the proposals we accept, then they decide which ones to publish. Now, then the schedule needs to be published. Now, the moment you publish a schedule, the speakers adjust their arrival times to jet, their flights or their trains or whatever the case may be, right? Their agendas, they block that out in their agenda. So afterwards, you really cannot change it anymore, the time of a time slot, or you need their approval when you do so. So you get a whole bunch of speaker and availability requests before you need to publish, so you take those into account, so you make sure you have a schedule that adheres to those. And then you get a whole bunch after you publish. Usually when you publish, there are some people say, okay, but I really can't because I already have an appointment and I forgot to tell you as an organizer. So you need to take those into account, and these come up later after you published. But again, the moment you've published, people adjusted their schedule accordingly. And then, of course, you have the other things that might affect the schedule, especially the room, like favorite voting. So you want to rerun the solver with minimum disruption. So how do we do that there? Well, what we do is on the talk, so a talk is assigned to a specific time slot, right? But we also keep track of the published time slot, which starts out as NULL. So basically, once we say we're going to schedule, so we solve a problem with OptaPlanner solver, right? All the talks get assigned to a time slot. Then we publish it by basically copying this value into the published time slot value. And then when we get new input data, like for example, this speaker isn't available during that period, and now we need to rerun the solver, what we say is, okay, we're going to rerun the solver. So some of the talks will get assigned to new time slots, but we're going to add a constraint, as you can see here written in constraint streams, that we want to minimize the number of talks that gets assigned a new time slot that differs from the published time slot. So what we're saying is we're going to take a talk. If that talk's published time slot is actually, if it's actually published, that talk, so if the speaker was informed this is when your talk will be, and then we're going to check if the new proposal of that time slot, which hopefully solves our hard constraint that now one of the other speakers is not available, so we switch that with this talk with another speaker's talk. We're going to check if that time slot is the same as the published time slot. And if they're not the same, then we have a problem. We don't want to do that. We want to minimize it as much as possible. In fact, we only want to do that, and then we want to do it with a medium constraint. Why a medium constraint? We only want to change a speaker's time slot if it helps us to solve a hard constraint, because there's a new hard constraint in town that speaker Anne is unavailable on Monday, so we're going to switch her talk with Beth's talk, and so we're only going to switch that if it actually reduces the number of hard constraints, and we won't care about the soft constraints, right? So basically, if it reduces some of the soft constraints, we're not going to do it because then it's not worth it, because we have to call Beth, right? We have to call Beth and get her approval, and she might not approve. And if we have get approval from 10 speakers to get back to a feasible schedule, they all need to agree. If one of them disagrees, we're back at square one potentially. So that's normal. That's non-disruptive replanning with a medium penalty. So we disrupt only to become feasible again, right? Because there's new input data makes the original schedule unfeasible, even though it was feasible when we delivered it, when we published it. And there's also a soft penalty, disrupt if the gain is higher than a threshold. So in that case, we're saying, okay, you can actually disrupt the schedule as long as the gain is higher than if it's worth it, right? So for example, the room in conference scheduling, that's also published, but that can change far more easily because that doesn't affect people's arrival times and so forth. It's just their rooms, right? So we're much more freely there. So that's a soft penalty we're using there. I'm going to skip this, but this is basically the same idea on cloud balancing, where we say, yes, there's an optional, there's an original solution, but the problem that changed is computer broke down, where we have the disruptive solution, which is the highest possible solution, the best possible solution, the optimal one here. But we're not going to take that because it disrupts too much, too many things have to change. We're just going to go for a non-disruptive solution where we have far less movements, right? And this one is done with soft constraint, actually, right? Okay, so the next question is, and I'm running out of time, so
Don't worry. Yeah, go through it. It's exciting. Please go on.
Thank you, Karina.
Like something like 5 or 7 minutes later, so please go on.
Thank you, Karina. So it's the first time I'm doing this talk, and I'm running a little bit on my time.
That's why it's exciting. It's fresh new.
Thank you, Karina. So, does your problem change every few milliseconds, or every few seconds? Then we need to talk about real-time planning. Why? Because when you running the solver takes some time too. It could take maybe 5 seconds or 30 seconds or 5 hours, right? Usually somewhere between 30 seconds and maybe an hour, but that people run it. But that actually, you lose that time, right? So sometimes you want to have very quick responses. I can show a quick demo on that, but basically here we have the cloud balancing problem. We have a number of computers being assigned to processes, and what we can actually do in real time, click here to delete the computer, and OptaPlanner will these processes which are assigned to this computer will go unassigned, and OptaPlanner will then in real-time planning accept that change and immediately start assigning them again, right? And the whole entire thing takes 12 milliseconds. So don't blink when I push the button, right? So see, you didn't even see them appear at the top, or at least I didn't. And that's just because of the how fast it is. I can show you in the logs. If you watch the logs here, and you go to the run here, over here, we do look for restart. Okay, I've let it run too long already. But if you can actually see that the restart happens. Let me just do it again. Okay, it needs to solve, of course. We're solving. We kill this computer over here, right? And then we look for restart. I'll just kill it. You can see the solver restarted. And if you actually look at the timings here, this is the scheduling of the event at second 11, and this is the restarted one at 11 seconds. And this is the end of the construction heuristic at 11 seconds, and at which time we're already feasible again, right? So all of the things are already assigned again. So that's really, and you can look at the milliseconds on how long it takes, but it's really not much time. Okay, so here we go. So real-time planning, basically we have a nightly plan, and then as the time goes by, we get new visits that get added in real-time planning, for example, vehicle routing, and we adjust our plans accordingly to pick those up. And as we actually do certain tasks, those tasks get pinned. Again, the use of planning pin is actually quite often here, right? And then of course, when you hear the yellow vehicle visit this customer, you can see all of these things get pinned, all the dark ones get pinned. And then, of course, as new customers come in, we adjust our plans accordingly. So that all uses the solver at problem fact change. The thing to know there is we have something called a daemon mode, which you can turn on. And why is a daemon mode? Basically, you don't want to waste CPU resources at the middle of the night, because when you have a solver running, and it's been optimizing for a while, and there's no real-time problem facts coming in, so there's no new customers that need to visit. The problem isn't changing, and it's always still solving. It's still taking CPU time. And what you can actually do is you can say, okay, I'm going to add a termination that says if there's no new input for a while, and your score has stabilized, and you don't find any improvements anymore, just block instead of actually using CPU resources. So the solver doesn't stop, it blocks in the daemon mode. And then as soon as a new problem fact comes in, it fires up again. So here we can see that. We provision, this is a case where we actually want to start as a separate pod. But basically we say, okay, we add the vehicles, and then we add visits, and every time, this is a problem fact change, every time we add a new visit, it's actually, if you look at the log, the OptaPlanner is restarting in like 10, 12 milliseconds, right? And then new solutions come out, right? And the client accepts those. But if no new problem fact changes come in, and so no improvements for 20 minutes, it's actually going to go into this blocked state. This is the daemon mode. And it's going to just sit there because it says, okay, I can't really find better solutions anymore, no new best solution. I'm not going to continue wasting CPU resources. It's good enough. And then when a new problem fact comes in, it's a restart, and it starts solving again until again it hits that no improvement for 20 minutes, right? And of course you can configure all this, but this is interesting to keep in mind. Daemon mode can really be very good for the environment, because this is don't waste CPU resources and heat and electricity if you don't need to anymore, right? And then the last bit I want to jump into is the over constraint planning. And so what is this? Is that you have a resource shortage, right? You have too few nurses, too few employees in this case, we have too few CPUs, too few machines to actually do all of these processes. And you can see if we all schedule them, we always have at least 2 CPU too little. So what you basically do is, what you want to do is you want to have one of the resources unassigned to a null, right? That's one way of doing it. And the problem is if you just assign all entities by default, you will break the hard constraint, but this is not a solution, because by default, OptaPlanner will assign every entity to a planning variable, never to null. Unless, of course, you say nullable is true. If you say planning variable nullable is true, then it will assign it there. And then you need to add a medium constraint, which checks, okay, how many of these are unassigned? And again, you penalize that, right? And you're probably wondering, what if I have over constraint planning, and if I have non-disruptive planning where I also have a medium constraint, how do I do that? You could actually use a bendable score to have 4 levels. So you can have hard, medium, next medium level, and then soft. Or you could just sum them up in the medium level as you see fit, right? But anyway, combine these as you see fit. That is not a problem. So, like I said earlier, planning variable nullable is true. There's another way, that's virtual values of virtual resources. Christopher talked about that 2 days ago. Do take a look at his session on that. But basically, you add extra employees, which are virtual, and then you add in constraint that penalize the use of these, because basically these are interim employees, right? Or freelance employees that you hire on the spot, right? Consultants. And these are, of course, far more expensive than your normal employees. But sometimes you just need them to have a feasible solution for your problem. You cannot say in the hospital, freelance nurses are a well-known fact in hospitals. You cannot say we're not going to deliver our service to the patients, right? And the last one, we'll just skip quickly, is if you fear a worst case scenario, you want to look into backup planning. So what is backup planning? Is the way of adding constraints into your problem such that when something bad happens, there is no worst case scenario. At least the worst case scenario isn't that bad. So for an example in hospital bed planning is that instead of just allowing, it's trying to keep one bed open. Why is this a good thing? Then when a new admission comes in, a new patient comes in for a certain amount of period, it's likely you're going to have a continuous bed open for amount of time, right? Other examples of this are having reserve employees, having employees assigned to a reserve shift, which actually spans the entire day, not particular 8 hours, such that when somebody calls in sick, you can actually just use that nurse. That's called backup planning. And this could be a presentation on its own, so I'm just going to continue here, right? So don't make your plan a house of cards where you remove one card and the whole plan falls in. Even though it might look perfect as a house of cards, you may add them some robustness by adding constraints in the plans to make sure, which are domain specific, to make sure that when something bad happens, that it works out. So this is my presentation. So just want to remind you, know your toolbox, in this case OptaPlanner. Know there's multi-stage planning, continuous planning, non-disruptive pre-planning, real-time planning, over-constraint planning, and backup planning. And I hope by seeing this presentation, you get a good grip on what all of these things are. And you can combine them as needed. Yes, you can do continuous planning with real-time planning and non-disruptive planning and all these things together, but they are not Pokemon. You do not need to catch them all. Keep it as simple as possible. Only use the ones that your business requirements require you to use, of course. Thank you for watching.
Wow, Geoffrey! I just removed your screen from the screen sharing, so wow. They're not Pokemons? Oh, Geoffrey.
You collect them all.
Yes.
So the left one is over-constraint Osaurus, and the right one is backup planning Osaurus, right?
Right. I have to have a backup. So, hey, Duncan.
You know what the thing is? I actually know the names of those Pokemon, so I left the
I know them all.
Yeah.
I know them all. So
you're the one who can answer that question. You're the one who can answer that DevOps pub quiz question. We know which of these frameworks are Pokemons and which are actually cloud frameworks.
That's a difficult one, eh? That's a difficult one. Yeah. I bet my son could answer that question better than I could. Yeah.
So, guys, let me bring a question from Nitin Otageri, whatever. So, Nitin, thank you for your question. With the flight crew scheduling example, if I want to delay the flight due to unavailability of the crew until someone is available, how can this be achieved? And if it's possible, is there a way to know how much the flights are going to be delayed?
It takes me a while to get back into the domain of the
that
flight.
almost sounds like over-constraint planning. It almost sounds like that you have to have a placeholder in place for the crew there.
If I recall correctly, you can already in the Excel, you can already specify that a particular pilot is unavailable. I can probably screen share that if you want for a second. If I recall correctly, we do have a couple of. there's a reason we don't have a video around it yet. There's supposed to be a taxi constraint in there, and we haven't finished that part of it yet. But if I recall correctly, if you open the, shall I screen share? I can. Oh, I am still screen sharing. Okay.
Do you want to share a screen? Okay, already there. Thank you.
Yeah. So if I recall correctly, in the input data here, yeah, you have unavailability already. So we can actually specify here Amy Green is unavailable on Monday.
Can you increase the font size? Thank you.
Yes, like this, I guess.
Better. Thank you.
Yeah. So here we can see Amy Green is unavailable. So those are already in there. Those get, I guess those are separate domain objects, problem facts. And then when we have an assignment during that time, it fails it, right? Yeah, let me go back. There we go. I hope that answers your question.
Yeah, I think the question goes a bit deeper. I think the question is more that if you have assigned a crew to a flight, right? If we want to delay the flight due to unavailability of the crew, the thing is that crews get assigned to flights a couple of days in advance, right?
Yeah.
I know that because one of my friends is a pilot, so he sometimes tells me about how that works. I think the question is like the crew is actually delayed, and so it's unavailable. So how do you delay the flight in that case?
Yeah. And that would be a good case of two planning problems with a different publication moment, right? Which basically means two different planning problems, two different solvers. So I would argue that's a separate solver. That's not the flight crew scheduling example. Probably can reuse a lot of the domain, but it's probably different.
Well, you're actually scheduling the flight itself, not the crew.
Ooh,
yeah. Well, it's the last day. It's one of those. This is one of those last day with a beer questions.
There's a polemic question on the chat from Benjamin. But Benjamin, hold on. I'll bring your question in a while. Let me first bring this one from Noel because we have lots of questions here, guys. So does OptaPlanner use traditional CSP techniques such as R consistency and etc.? Or are there any correlations between meta heuristics and traditional CSP?
So the short answer there is no. OptaPlanner does not use those constraint satisfaction programming techniques. That's quite interesting. So OptaPlanner is really good at scaling out. Meta heuristics are great at scaling out. They typically win the academic competitions on scaling out and so forth. When you really want to scale down to small problems with just a few vehicles and so forth, or a few, maybe just a few locations, right? 10 visits, 3 vehicles and so forth. You're going to see that these CSP solvers probably do a quicker job, I must say, even though I'm of course biased towards OptaPlanner. But once you start scaling out to anything medium or high, CSP solvers, I've never seen them in production. They are, but they have very interesting techniques. R consistency, yes. There's more like how they deal with diversity and stuff like that. I don't really grok that, but they had some really. So what they do is they limit their value ranges, and there's probably some things we can do, and there's probably some research around this too, to automatically limit the value range. So one of the things we have been thinking about this is very basic 101s, is that if a planning variable has only one, its value range has only one value, we don't need to try that value. We can just assign that value, right? CSP techniques go much further. Actually, their whole solving is based upon this principle. CSP techniques is brilliant for the Einstein problem, where basically you have solve the zebra problem. In which house has the zebra or stuff like that. I don't know if people know this problem, and they work really well. Or Sudoku. Yeah,
I don't know this problem.
It's the Einstein puzzle or the zebra puzzle. You should look it up on Wikipedia. It's a fun one, but it's and basically with some logic you need to figure out it's like Sudoku. If you know Sudoku. It's very similar. Yeah. But so the answer is unfortunately not yet. Maybe we want to invest in. We're looking into more approaches, and there's a couple on our list to actually improve the quality of our solvers even better, and expand our algorithms and so forth. This one is not on the short list, though, on the short backlist. But it's good to know about this, and thanks for sharing.
Oops, awesome, great answer. So, do you want something polemic now or later?
For me, it's good, you guys. Go for it.
Are you ready, Duncan? Are you ready, Satish? So, okay. If you had to make OptaPlanner from scratch,
I knew that one was coming. Please say JavaScript. Please say JavaScript.
I would say JavaScript if I have like 5 seconds to live, then it's good for me. Good luck, guys. Here's my legacy.
I would know. I would have a I would know. Although I haven't written it, but I would write it in Python. And the reason I would write it in Python is because there's a lot of AI people that are really good in Python or R or those kind of languages. We get a lot of requests how you can bridge the gap or how they can use the OptaPlanner solvers in some of their AI work streams and their use cases. So my answer would be Python.
Yeah, makes sense.
Guys, I mean, just a kind of a trivia or a brief memory that I have. Before joining Red Hat, I was in a company where I was part of the kind of chief architect, and one of the projects was building a custom rule engine. And yeah, believe it or not, we built it on .NET and C#. Now, C# is helpful because it was a kind of copy of Java. But the amount of pain we went through, never again. Okay, so all I'm trying to say is that the choice of technology in building something where a lot of goodness of Java, the object-oriented and all those things is something which you can't find anywhere else. So Python may be a good choice, but not many choices are there if you have to take this question seriously. Apart from that, the Java is equal to slow. That has been kind of remedied to a certain extent with Quarkus. And this is where, if those complaints about Java are mostly due to the performance and speed and all those things, there are other ways to handle that. So
yeah, I agree, and it's also usually one of the arguments is the verbosity of Java. I can do this in 1 line, and you have to write 5. I've never understood that argument because my 5 lines usually are pretty readable, where those 1-liners are really. You got these funny comments that you see on the internet. When I wrote this code, both God and me knew what it did. Now only God knows. And it's what you say, Satish. I think also one of the strengths of Java and that benefits OptaPlanner projects, that really benefits OptaPlanner projects is the large ecosystem around Java. It's like also with the new advancement and the new features in Java, and still the large investments of large companies in Java, that we can now do things with Quarkus, do native compilation of things. That's all things that the large Java ecosystem brings, and that OptaPlanner can greatly benefit from.
Yeah, especially the argument that Java isn't fast. I mean, that was Java 1.0. We're now at Java 11. That's been gone since 1.4 or something like this. It's been 15 years, guys. Give me the rest.
Exactly.
25 years of Java. 25 years of Java.
15 years that you cannot. That there's no single benchmark. Unless, of course, the startup time. But if you're looking at actually the when it's warm, Java is always faster these days. Startup time, that's interesting. That's where Quarkus and native compilation is just a game changer for us. It's an interesting question. My answer would be the same as Duncan's. If I would be smart, say we need to use Python because we cannot use Java. I would use Java, of course, given if that was an option. Clearly, it's not from the question. I don't like Python. But that would be the smart option, but I wouldn't do it because it's not the type safety lacks and so forth. But one of the things we're looking
Of course,
at,
you would do it. I would force you.
Yes. But the interesting thing about this is how can we make it easier for Python users to use us? Because we've had this before, C# users. People asking me, when are you going to port this to C#? And the answer was not this year. Open REST APIs more easily.
Maybe nowadays with Growl.
Generate REST services.
With Growl, there might be an option with the truffle library on top of Growl. That would be an interesting research topic. So if any university is looking for a nice research topic, doing a OptaPlanner API native Python using the truffle platform on Growl VM, there you go. There's your master thesis.
Yeah, absolutely. And of course, I need to mention. So Python would be the smart choice, but if I cannot use Java, I want to use Java. That's still a great language. You have an ecosystem. People don't want to use it, but if you have to make a choice, it would probably be Kotlin. It's the only language of silent, but that's a bit of a sad story there. But Kotlin is the only language that at least gives you something that is readable besides Java. I mean, many of the others are still readable, but that really says a language is read 10 times more than it is written, right? And not vice versa. It's not goes for writing speed, it goes for reading speed. And any project that goes in the long run must first focus on readability, because you still have to understand not 6 months later, but 6 years later or 16 years later, what that piece of code did. It does, right?
And it starts with a K, so that's a good choice.
Oh, yeah.
This is an easy question, actually. Easy is, as this is like it's a yes or no question. So, over constraint planning problem, in addition to real-time planning with 2 planning variables, and this planning variable is having a value range for each planning entity. Easy. Easy.
So
okay.
The answer is yes.
I saw the question earlier and I had to think for a minute, but I'm pretty sure it's yes.
Together?
Yeah, I'm pretty sure it's yes.
Yeah, so the answer is yes, but so over constraint planning, not worried about that. Real-time planning, not worried about that. 2 planning variables, that's where 2 planning variables on 1 planning entity, I'm not worried about that. These planning variables having a value range for each planning entity. Yes, of course, each planning variable has its own value range. If it's an entity-based one, might get interesting. So there's 2 things that's not in here that didn't make me go like, this gets interesting, this gets challenging. And so the first thing that I'm missing here to make this challenging is 2 planning entities. Once you have 2 planning entity classes, a lot of the default moves of OptaPlanner won't help you. So custom moves come into the picture, which means work, right? Come into the picture. This is something we want to improve in the long run to deal better with multiple planning entity classes. But there's very few use cases that need it, and far less use cases that actually should use them to begin with. And then, so that's not the question here. 2 planning variables, like in school timetabling, where you have a room and a time slot variable, that's fine. And the other one is chain variables. Chain variables have some rough edges when combined with over constraint planning, if I recall correctly. And we're looking into that. In fact, for chain variables, this is one of our big things that we are that's on our roadmap to really make it simpler to use.
Nice. Thank you, Geoffrey. What about hyperheuristics? Can you estimate when this will be available?
This is a product management question, roadmap question. Go for it, guys.
Satish wants to leave like. So basically, I think this can be seen from a different perspective. Like, is this a work in progress now, or is it on the backlog today?
It's on the backlog. So roadmap and giving actual estimates on things, especially, I mean, unless there's a customer relationship, we won't want to say we will deliver this by this date, because there's too many. It just changes too much. And a customer comes in and requests another priority, it just happens, right? But hyper heuristic specifically, very interesting case. So what is it? It's basically adjusting your algorithm, so like tabu search or similar needing, based upon the data that comes in, or actually doing it at runtime, trying multiple, and then basically doing meta heuristic on top of meta heuristics. It's like meta heuristics, but that was a terrible name, so they called it hyper heuristics. I've seen some users do it partially by using the solver config. So what they do is they look at the data set coming in, they see, oh, it's a big data set, I'm going to use this type of solver config, or I'm going to use that one. The results of that are mixed. I'm a much stronger believer in using techniques like multi-threaded solving and so forth.
Multi-bat.
Yeah, multi-bat if need be. Yeah. But this is a form of multi-bat, basically. Yeah. But real hyper heuristics go much further, and we'd love to do those on the backlog.
Nice, thank you. So those questions like, Geoffrey, where do you see yourself in 10 years? So there's a similar one coming. So what is the future of OptaPlanner? Where do you see it in 12 months?
Let me ask you guys, what do you think that OptaPlanner should be in 12 months?
Ooh.
Cloud, baby. It should be in the cloud.
Wow,
that was an easy answer, right?
Yeah, no, I'm serious. We see a lot of movement to cloud. Container platforms are the hype of the day. Everybody's investing in that. If there's opportunities there for OptaPlanner as well, especially, well, you've invested a lot in the solver manager, for example, to run multiple solver jobs at the same time being managed by that solver manager. I can see that at some point we want to invest in having those jobs run in separate containers and utilize the power of things like Kubernetes for those kind of scheduling and those kind of jobs. So that was a serious answer.
Yeah, absolutely. And we actually have people writing that kind of boilerplate today already, right? Justin Goldsmith, who spoke yesterday, has set up something like that already for some of our customers. And but everybody has to do it again and again. And if we provide the plumbing, an extension that does it for you, it won't be part of OptaPlanner core. It will be in a separate module, of course, maybe a Cogito module, and then but we need this. Yeah,
this would be part of maybe OptaPlanner ecosystem. Right? Definitely. We started 14 years ago. Let's see where we are in 14 years.
Yeah.
Ooh. So guys, I know that our chat is really, really good and exciting, but we are past our 20 minutes. So I'd like to bring a couple of wrapping words. So first of all, thank you all for attending to the OptaPlanner Week. It was amazing. It was super exciting. I learned so much with these guys. They are brilliant. Thank you, Geoffrey, for all the support and for being here the 3 days. Thank you, Duncan, for being Duncan, right? You're always helpful with everything. And for idealizing the event, the idealizer of the event. So thank you, Satish, for being with us today and for your talk. And I'd like to say that we say to you, if you registered on the event, on Eventbrite, we've sent you a survey. We would highly appreciate if you could fill it out so that we can improve for next upcoming events that we might do. We also would like to say that all the slide decks will be available for you, as well as the presentations. So you'll be able to watch the same presentations like the full day on YouTube, on the key YouTube channel. So make sure you subscribe in there, hit the like button. And also we will provide the talks separately so you can rewatch the ones you'd like to recap. So that's
also,
all.
Karina, I saw a number of questions still on the chat that we haven't been able to answer. If you want those questions answered, please go to our Zulip. You know where to find us. We're around, and we're always happy to answer your questions.
Exactly, Duncan. So let's keep in touch. We are all the engineers are in there. The guys from sales team, from services team. Duncan is there too, because Duncan is a mix. He's in there for everything. So if you need coding, Duncan's there. If you need support, Duncan's there. If you need product management, Duncan's there. So
if you need
somebody to drink a beer with, yeah, exactly, Satish. See, we know each other. Oh man, exactly.
So yeah, join us on.
I'd like to say, Karina, thank you so much for organizing the last 3 days, for hosting the last 3 days. You did an awesome job. And this is really something that we need to make this an annual event. This was very nice.
Perfect. And someone asked if we would do this in person. Yes, once the situation comes back to normal, we might do this in person, like some local meetups. We could do a world tour.
Looking forward to that.
Yes, and a couple of beers. So that's it. Thank you all. Wish you all a great rest of the week. See you on the lab. Bye-bye. Thank you, Geoffrey. Thank you, Satish.
Bye-bye.
Thank you, Duncan. Thank you.